the ultimate coding escape, where learning meets relaxation. Find a cozy spot, dim the lights, and let the gentle rhythm of this tutorial start to wash over you. As we explore the world of Visual Basic together, may your mind unwind and your spirit find peace in every line of code. Don't forget to like this video and subscribe for more soothing sessions that turn programming into a calming ritual. Let the journey begin. Good day. Today, we will begin our journey into the world of Visual Basic programming. This session is designed to provide a solid foundation by exploring the basics of the language and its core principles. By the end of this session, you will have a clear understanding of what Visual Basic is, how it fits into the broader landscape of software development, and why mastering programming concepts is essential for any developer. Our agenda today includes an in-depth look at key concepts, the unique features of Visual Basic, and practical examples that demonstrate its application in real-world scenarios. Let's begin by defining what Visual Basic actually is and why it remains a relevant tool in modern programming. Visual Basic, often abbreviated as VB, is a high-level programming language created by Microsoft to simplify the process of building applications. It is part of the larger .NET framework, which provides a comprehensive set of tools and libraries for developers. What sets Visual Basic apart is its focus on ease of use, particularly when it comes to creating graphical user interfaces. This makes it an excellent choice for beginners and experienced developers alike who want to rapidly prototype or develop Windows-based applications. Unlike lower-level languages that require deep knowledge of hardware interactions, Visual Basic abstracts many of these complexities, allowing programmers to concentrate on solving problems rather than managing system-level details. As we progress, we will see how this design philosophy translates into practical coding scenarios. To effectively use Visual Basic, it is crucial to understand its core programming concepts. Variables and data types form the building blocks of any program, as they allow us to store and manipulate information. Control structures, such as if-else statements and loops, enable programs to make decisions and repeat tasks, adding flexibility to our code. Functions and procedures help organize code into reusable components, improving efficiency and readability. Finally, object-oriented programming principles, including classes, objects, and inheritance, provide a structured approach to designing complex applications. These concepts are not unique to Visual Basic, but are fundamental to programming in general. Mastering them will empower you to write clean, efficient, and scalable code regardless of the language you choose. Visual Basic offers several features that make it a powerful tool for developers. The Integrated Development Environment, or IDE, provides a centralized workspace for writing, testing, and debugging code, streamlining the development process. Its event-driven programming model allows applications to respond to user actions, such as button clicks or mouse movements, making it ideal for interactive software. The language also includes a rich library of pre-built components, which reduces the need to write code from scratch and accelerates development. Additionally, with the advent of NetCore, Visual Basic now supports cross-platform capabilities, enabling applications to run on multiple operating systems. These features collectively make Visual Basic a versatile and accessible choice for a wide range of projects. Programming concepts are the backbone of any successful software development effort. They form the foundation upon which efficient and scalable code is built. By understanding variables, control structures, and functions, you gain the ability to break down complex problems into manageable parts. Logical thinking and problem-solving skills are honed through practice, allowing you to approach challenges systematically. Furthermore, these concepts enable interaction with databases and external systems, which is critical for developing real-world applications. Whether you are creating a simple utility or a large-scale enterprise solution, a strong grasp of programming fundamentals will serve as your guiding principle. As we move forward, these ideas will become even more apparent through hands-on examples. To summarize, Visual Basic is a versatile and user-friendly language that remains relevant in modern software development. Its integration with the Net framework, combined with its emphasis on simplicity, makes it an excellent starting point for learning programming. However, the true power of any language lies in the understanding of its underlying concepts. By mastering variables, control structures, and object-oriented principles, you will be well equipped to tackle a wide array of programming challenges. In our next session, we will dive into hands-on coding exercises to apply these concepts in practice. I encourage you to review today's material and come prepared explore the practical side of Visual Basic. Let's continue building the skills needed to create meaningful and functional applications. A development environment in Visual Basic programming serves as the workspace where you write, test, and debug your code. It provides essential tools like a code editor, debugger, and compiler to streamline the development process. Proper setup is crucial because it ensures a smooth workflow, reduces errors, and allows you to focus on learning the language rather than troubleshooting technical issues. The primary tools required for Visual Basic include Visual Studio, which is the integrated development environment, and the Net Software Development Kit, which provides the necessary libraries and runtime support for building applications. To begin, you need to download the appropriate version of Visual Studio, such as the Community Edition, which is free and suitable for most learning purposes. During the installation process, make sure to select the Visual Basic workload, as this ensures all the necessary components for VB programming are included. Additionally, verify that the Net SDK is installed, as it is essential for compiling and running your applications. The SDK also ensures compatibility with different versions of the Net framework, allowing your projects to function across various platforms. Once Visual Studio is installed, open the application and click on Create a New Project to start a fresh development session. From the list of templates, choose Visual Basic as the language and select a project type that suits your needs, such as a console application for basic programs or a Windows Forms app for graphical interfaces. Next, give your project a meaningful name and choose a location on your computer to store the files. These steps are fundamental in organizing your work and making it easier to locate and manage your projects later. The Visual Studio IDE consists of several key components that you will use regularly. The Solution Explorer displays all the files in your project, allowing you to navigate and manage them efficiently. The Code Editor is where you write and modify your Visual Basic code, with features like syntax highlighting and auto-completion to enhance productivity. The Properties window lets you adjust the characteristics of controls and objects in your application. The Toolbox provides drag and drop functionality for adding UI elements, which is particularly useful when building graphical user interfaces. Familiarizing yourself with these tools will significantly improve your ability references to your project allows you to incorporate external libraries or assemblies that provide additional functionality. To do this, right-click on your project in Solution Explorer and select Add Reference. This opens a dialog where you can choose from available net frameworks or third-party tools. For example, you might add a library for handling data encryption or integrating with external APIs. Managing dependencies carefully is essential because missing or conflicting references can cause your application to fail. Always ensure that all required libraries are included and up to date. Configuring your project settings is a critical step in tailoring the development environment to your needs. Access the project properties by right-clicking on the project and selecting Properties. Here, you can set the build configuration to debug for testing or release for final deployment. Adjust the target framework to specify which version of the net platform your application will use, and set the platform to x86, x64, or any CPU based on your requirements. You can also customize the output path to determine where the compiled files are saved and modify compiler options to optimize performance or enable specific features. To verify that your setup is working correctly, write a simple "Hello World" program. This classic example demonstrates the basic structure of a Visual Basic application. Type the code, such as console, write line "Hello World," and then run the application using the Start button or the keyboard shortcut F5. If everything is configured properly, the program will execute and display the message in the console. If errors occur, such as missing references or incorrect settings, review the error messages and adjust your project configuration accordingly. Troubleshooting these issues is an essential skill for any developer. In summary, setting up a Visual Basic development environment involves installing the right tools, configuring project settings, and testing your setup to ensure everything works smoothly. A stable and well-organized environment is the foundation for all future projects, saving time and reducing frustration. As we move forward, the next session will focus on writing your first Visual Basic program, building on the setup we have just completed. This will mark the beginning of your journey into programming with Visual Basic, and I look forward to guiding you through the process. Variables are essential components in programming because they allow us to store and manipulate data can change while a program is running. When we declare a variable, we must give it a name and specify the type of data it will hold. This process ensures that the program knows how much memory to allocate and what operations are possible with that data. For example, the line dim age as integer equals 25 demonstrates how a variable named age is created to store an integer value. The rules for naming variables are important to follow, such as avoiding spaces, starting with a letter, and using meaningful names to make the code easier to understand. By adhering to these conventions, we create cleaner and more maintainable code. Understanding data types is crucial because they define the nature of the information a variable can store. Each data type has specific characteristics, such as the range of values it can hold and the amount of memory it requires. For instance, an integer type is used for whole numbers, while a string type stores text. This distinction helps prevent errors and ensures efficient use of system resources. Consider the example dim name as string equals John, where the string data type is chosen to hold a sequence of characters. Other common types include Boolean for true or false values, double for decimal numbers, date for time-based information, and object for more complex data structures. Choosing the correct data type is a fundamental step in writing reliable and high-performance code. In Visual Basic, several data types are frequently used to handle different kinds of information. An integer is ideal for storing whole numbers, such as 100 or -5. Strings are used for text, like the word hello, and are essential for handling user input or displaying messages. Boolean values are limited to true or false, making them useful for decision-making in programs. Doubles are designed for floating point numbers, which can include decimals like 3.14, and are often used in calculations requiring precision. The date type allows for storing and manipulating time-related data, such as a specific day or time. By selecting the appropriate data type for each variable, we ensure that our programs are both efficient and easy to work with. Constants are values that remain unchanged throughout the execution of a program, making them a powerful tool for improving code clarity and reliability. Unlike variables, which can be modified, constants are set once and cannot be altered. This is particularly useful for values that are used repeatedly, such as the mathematical constant pi, which is often represented as 3.14159. The syntax for declaring a constant is straightforward, using the keyword const followed by the data type and value. As in const pi as double equals 3.14159. By using constants, we reduce the risk of accidental changes and make the code easier to maintain, especially when the same value is referenced in multiple places. To summarize, variables and constants serve distinct roles in programming. Variables are used for data that can change, while constants are fixed values that enhance readability and maintainability. Selecting the right data type for each variable ensures efficient memory usage and prevents errors. Proper naming conventions and declaration practices are vital for creating clean, understandable code. As you continue learning Visual Basic, practicing the use of variables, data types, and constants in real-world scenarios will reinforce your understanding and help you develop more robust applications. Always remember that attention to these details lays the foundation for writing effective and professional code. Operators are symbols that perform operations on variables and values. In Visual Basic Net, these symbols are essential for manipulating data and creating logical or mathematical expressions. For instance, you might use an operator to add two numbers, compare values to make decisions, or combine conditions in a program. Understanding operators is fundamental because they form the building blocks of any expression, allowing you to write dynamic and responsive code. Whether you're calculating a result, checking a condition, or modifying data, operators are the tools that enable these actions. Mastery of operators helps you construct precise and efficient programs, making them a critical area of focus for any programmer. Arithmetic operators in Visual Basic Net include plus, minus, asterisk, slash, backslash, and mod. The plus operator adds two numbers together, such as 5 plus 3, resulting in 8. The minus operator subtracts one number from another, like 10 minus 4 yielding 6. The asterisk operator multiplies two values. For example, 2 multiplied by 5 equals 10. The slash operator divides one number by another, such as 15 divided by 3, resulting in 5. The backslash operator performs integer division, returning only the whole number part of the division, like 17 divided by 5, giving 3. Finally, the mod operator returns the remainder of a division. So 17 mod 5 equals 2. These operators allow you to handle numerical calculations with precision, making them indispensable for tasks ranging from simple math to complex data processing. Comparison operators in Visual Basic Net are used to evaluate relationships between values. The equal sign checks if two values are identical, such as 5 equals 5, which returns true. The not equal sign, represented by less than and greater than symbols, determines if two values are different, like 5 not equal to 3, which is also true. The greater than symbol compares if one value is larger than another, such as 10 greater than 7, which is true. The less than symbol checks if one value is smaller than another, like 3 less than 6, which is true. The greater than or equal to symbol evaluates if one value is either larger or equal to another, and the less than or equal to symbol checks if one value is smaller or equal to another. These operators are crucial for decision-making in programs, enabling conditional logic and comparisons that drive program behavior. Logical operators in Visual Basic Net allow you to combine or negate conditions. The AND operator returns true only if both conditions are true, such as checking if a value is greater than 5 and less than 10. The OR operator returns true if at least one condition is true, like checking if a value is either greater than 5 or less than 3. The NOT operator reverses the logical state of a condition. For example, if a value is not equal to 0, the XOR operator returns true if exactly one condition is true, making it useful for exclusive scenarios. The AND also operator functions as a short circuit, and meaning it evaluates the second condition only if the first is true, improving efficiency. Similarly, the or-else operator evaluates the second condition only if the first is false, which can prevent unnecessary computations. These operators are vital for creating complex logical expressions that control program flow and decision-making. Expressions in Visual Basic Net are combinations of variables, constants, and operators that produce a result. For example, an expression might add two numbers, compare values, or combine conditions. The order in which operations are performed is determined by operator precedence rules, where certain operations like multiplication take priority over addition. For instance, in the expression 5 plus 3 multiplied by 2, multiplication occurs first, resulting in 11. Parentheses can override this default precedence, allowing you to control the order of operations explicitly. For example, adding parentheses around 2 plus 3 before multiplying by 4 changes the result to 20. Understanding these rules ensures that your expressions behave as intended, avoiding unexpected outcomes and making your code more predictable and easier to debug. When working with operators, it is important to avoid ambiguous expressions that may lead to errors. For example, without parentheses, an expression like 5 plus 3 multiplied by 2 might be misinterpreted. Using and also and or else instead of and or can improve efficiency by short-circuiting evaluations, preventing unnecessary checks. Additionally, be mindful of the difference between the equal sign used for assignment and the equal sign used for comparison, as they serve different purposes in code. Testing complex expressions with sample values helps verify their correctness, ensuring that your logic works as expected. By following these best practices, you can write clearer, more reliable code that is easier to maintain and understand. Operators are the foundation for manipulating data and making decisions in Visual Basic Net. They enable you to perform calculations, compare values, and create logical conditions that drive program behavior. Mastering how expressions evaluate, including operator precedence and the use of parentheses, ensures that your code is accurate and efficient. Practicing with real-world scenarios helps reinforce these concepts, allowing you to apply them confidently in various programming situations. By understanding and utilizing operators effectively, you can build robust, functional programs that solve real problems and meet user needs. Control structures are the foundation of programming logic, allowing programs to make decisions and execute code in a structured way. They determine the order in which instructions are carried out, enabling programs to respond to different situations. These structures are essential because they let you control the flow of your code, whether it's making a choice based on a condition or repeating a set of actions. In this session, we will focus on 2 key control structures: the if statement and the select case statement. These tools empower developers to create dynamic programs that can adapt to various inputs and scenarios. Understanding these structures is crucial for writing efficient and readable code. The if statement is one of the most fundamental tools in programming for making decisions. It allows your code to execute specific blocks of instructions only when a particular condition is met. For example, if a variable meets a certain criterion, the program can take one path. Otherwise, it can take another. The syntax of the if statement is straightforward. You start with the keyword if, followed by a condition, then the keyword then, and finally the code that should run if the condition is true. After that, you close the statement with end if. This structure can be extended with else if to handle multiple conditions, and else to provide a default action. For instance, you might use an if statement to check whether a number is positive, negative, or 0, allowing the program to respond appropriately to each scenario. Nested if statements take the concept of decision-making a step further by allowing one if statement to be placed inside another. This is useful when you need to evaluate multiple conditions in a hierarchical manner. For example, you might first check if a variable is greater than 0, and then, within that block, check another variable to determine further actions. While this can be powerful, it's important to use nesting judiciously. Overly deep nesting can make code difficult to read and maintain, leading to potential errors. To keep your code clean, it's best to limit the depth of nesting and consider alternative approaches, such as breaking complex conditions into smaller, more manageable parts. The select case statement offers an alternative to multiple if-else statements when you need to evaluate a single variable against several possible values. Instead of writing a series of if conditions, you can use select case to specify different cases for different values of a variable. This makes the code more readable and efficient, especially when dealing with a large number of possible outcomes. The syntax begins with the keyword select case, followed by the variable you want to evaluate. Then you list each possible value with the case keyword, followed by the corresponding code to execute. Finally, a case else block can handle any unexpected values. This structure is particularly useful when working with enumerated types or fixed sets of options, such as checking a user's input against a predefined list. Choosing between if and select case depends on the specific needs of your program. The if statement is ideal for conditions that involve ranges, logical operators, or complex expressions. For example, You might use if to check if a number is between 10 and 20, or if two variables satisfy a particular relationship. On the other hand, select case is more efficient when you need to compare a single variable against multiple discrete values. If you have a variable that can take on several distinct values, such as a grade letter or a status code, select case provides a cleaner and more organized way to handle those cases. While if statements offer greater flexibility for complex conditions, select case improves readability and reduces the risk of errors when dealing with multiple fixed values. To write effective and maintainable code, it's important to follow best practices when using control structures. For dynamic decisions that involve ranges or logical combinations, the if statement is the preferred choice. However, when working with fixed values or enumerated types, select case is more appropriate. Avoid creating deeply nested if statements, as they can make your code harder to understand and debug. Instead, consider restructuring complex conditions into smaller, more manageable parts. Always include a case-else block in your select case statements to handle unexpected or invalid inputs, ensuring your program can respond gracefully to unforeseen situations. These practices will help you create code that is both functional and easy to maintain. Let's look at some practical examples to see how these control structures work in real-world scenarios. In the first example, an if statement checks whether a user's age is 18 or older. If the condition is true, the program displays a message indicating that the user is an adult. Otherwise, it shows a message for a minor. This simple structure is perfect for scenarios where you need to make a binary decision. In the second example, a select case statement evaluates a grade variable. Depending on whether the grade is A, B, or another value, the program displays different messages. This approach is much cleaner than using multiple if-else statements, especially when there are many possible cases. These examples demonstrate how control structures can be used to create responsive and user-friendly applications. In summary, control structures are essential for building programs that can make decisions and adapt to different situations. The if statement is versatile for handling conditions involving ranges or logical expressions, while the select case statement simplifies comparisons against multiple fixed values. By mastering these tools, you can write more efficient and readable code. As you continue your training, practice implementing these structures in various scenarios to reinforce your understanding. In the next session, we will explore loops such as for, while, and do until, which allow programs to repeat actions. These concepts will build on what you've learned today, further expanding your ability to create dynamic and powerful applications. Functions and subroutines are essential components in Visual Basic that allow programmers to create reusable blocks of code. These elements help in organizing the code base, making it more readable and easier to manage. By breaking down complex tasks into smaller, self-contained units, functions and subroutines enable developers to focus on specific operations. A key distinction between the two is that functions are designed to return a value, such as a calculated result, while subroutines perform actions without returning any value. This separation of concerns enhances code efficiency and clarity, allowing for more structured and maintainable programs. The primary difference between functions and subroutines lies in their ability to return values. Functions are defined using the function keyword and are used when a result needs to be passed back to the caller. For example, a function might calculate the sum of two numbers and return the outcome. Subroutines, on the other hand, are created with the sub keyword and are used to execute a series of actions without returning any data. They are ideal for tasks such as displaying messages, updating user interfaces, or modifying data. Understanding this distinction is crucial for determining which type of procedure to use based on the specific needs of the program. Functions serve a critical role in simplifying complex operations by encapsulating calculations and returning results. For instance, a function might compute the area of a circle or determine the average of a set of numbers. By isolating these tasks, functions make the code more modular, allowing developers to reuse them across different parts of a program. This modularity not only reduces redundancy, but also makes the code easier to test and debug. Additionally, functions promote code reuse, as they can be imported into multiple projects, saving time and effort in development. Subroutines are designed to execute a sequence of actions, making them ideal for tasks that do not require a return value. For example, a subroutine might display a message to the user, update a database, or modify the the appearance of a form. These procedures are particularly useful for handling user interface interactions, such as responding to button clicks or validating input. By breaking down large tasks into smaller steps, subroutines improve code structure, making it more organized and easier to follow. This approach also enhances collaboration, as multiple developers can work on different sections of the code without conflicting. The syntax for defining functions and subroutines in Visual Basic follows a clear structure. A function begins with the function keyword, followed by the procedure name and parameters. For example, the line function add numbersa as integer, b as integer specifies a function that takes two integer parameters and returns an integer result. The code block within the function uses the return statement to send the result back to the caller. In contrast, a subroutine starts with the sub keyword and does not include a return type. The code within the subroutine performs actions, such as writing to the console, without returning any value. This syntax ensures that procedures are well defined and easy to understand. Parameters and arguments play a vital role in how functions and subroutines interact with the rest of the program. Parameters act as placeholders for values that the procedure will use, while arguments are the actual values passed during the procedure call. For instance, in the call add numbers 3, the numbers 5 and 3 are the arguments that replace the parameters a and b in the function. This mechanism allows procedures to be flexible, as they can process different inputs each time they are called. Properly defining parameters ensures that the procedure can handle various scenarios, making the code more adaptable and robust. Return values are a defining feature of functions, enabling them to communicate results back to the caller. When a function completes its task, it uses the return statement to send the computed value. For example, a function named square that takes a double as input might return the result of multiplying the input by itself. This returned value can then be used in other parts of the program, such as performing further calculations or updating variables. Subroutines, however, do not have return values, as their purpose is to execute actions rather than produce results. This distinction ensures that functions and subroutines are used appropriately based on their intended purpose. Calling procedures in Visual Basic is a straightforward process that involves using the procedure name followed by the required arguments. For functions, the returned value is typically assigned to a variable, as seen in the example dim result, as integer equals add numbers 10, 20. This allows the result to be used in subsequent operations. Subroutines, on the other hand, are called directly without assigning a result, such as display message, hello. This approach ensures that the subroutine executes its actions without needing to return data. Properly calling procedures is essential for the smooth execution of a program, as it ensures that the correct data is processed at the right time. Adhering to best practices when using functions and subroutines can significantly improve code quality and maintainability. One key practice is to use descriptive names that clearly indicate the purpose of the procedure, such as calculate tax or display error message. This makes the code more readable and easier to understand for others. Additionally, each procedure should focus on a single task, avoiding overly complex operations that can lead to errors. Avoiding excessive use of global variables is also important, as it reduces dependencies and makes the code more modular. These practices contribute to cleaner, more efficient, and easier to maintain programs. In summary, functions and subroutines are powerful tools in Visual Basic that enhance code efficiency and maintainability. Functions are ideal for tasks that require returning a value, such as calculations, while subroutines are suited for actions that do not need a result. Understanding when to use each type ensures that the code is structured effectively. By practicing the creation of reusable procedures, developers can build more organized and scalable programs. These skills not only improve individual coding abilities, but also foster better collaboration and long-term project success. Arrays are a fundamental concept in programming that allow you to store multiple values of the same data type in a single variable. This makes it easier to manage and organize related data, such as a list of numbers, names, or other elements. Instead of declaring separate variables for each item, you can use an array to hold them all together. When declaring an array in Visual Basic, you use the dim statement, specifying the size or initial values. For example, the code dim numbers 4 as integer creates an array that can hold 5 integer values, starting from index 0 up to 4. This structure is particularly useful when dealing with data that has a predictable size, or when you need to perform operations on a group of items efficiently. There are several types of arrays in Visual Basic, each suited for different scenarios. The simplest is the single-dimensional array, which stores elements in a linear sequence, like a list of names. For example, dim names 2 as string creates an array that can hold 3 string values. Multi-dimensional arrays extend this concept to 2 or more dimensions, making them ideal for representing data in a grid-like structure, such as a matrix. The code dim matrix 2 as double creates a 2-dimensional array with 3 rows and 3 columns. Another type is the jagged array, which is an array of arrays, allowing each subarray to have a different length. This flexibility is useful when working with irregular data structures, such as a list of lists, where each list contains a varying number of elements. In addition to arrays, Visual Basic provides collection classes that offer more dynamic ways to manage groups of objects. These classes include ArrayList, Dictionary, Queue, and Stack, each designed for specific use cases. An ArrayList allows you to add or remove items at runtime, making it suitable for scenarios where the number of elements is not fixed. A dictionary stores key-value pairs, which is perfect for situations where you need to quickly look up data using a unique identifier. For example, you might use a dictionary to map student IDs to their names. A queue follows a first-in, first-out principle, ideal for task management, while a stack operates on a last-in, first-out basis, useful for scenarios like undo functionality. These classes provide more flexibility than arrays when dealing with changing data. When working with arrays and collections, there are several common operations you will perform. To add elements, you can use methods like add to append an item, insert to place an item at a specific position, or insert range to add multiple items at once. Removing elements can be done with remove to delete a specific item, remove at to delete by index, or clear to remove all items. Iterating through collections is often done using a for each loop, which simplifies the process of accessing each element. Alternatively, you can use getNumerator for more control over the iteration. Accessing elements in an array is straightforward using an index, while dictionaries require using a key to retrieve the corresponding value. These operations form the backbone of manipulating data in your programs. To ensure your code is efficient it's important to follow best practices when using arrays and collections. First, choose the right data structure based on your needs. Arrays are best for fixed-size data, while collections are more suitable for dynamic data that changes over time. Use for loops when you need to access elements by index, and for each loops when you simply need to iterate through all items. Always handle exceptions, such as invalid indices or null references, to prevent runtime errors. For example, checking if an index is within bounds before accessing an array element can avoid crashes. Additionally, optimize performance by pre-allocating array sizes when possible, as resizing arrays dynamically can be computationally expensive. These practices will help you write cleaner, more reliable code. In summary, arrays and collections are essential tools for managing multiple data items in Visual Basic. Arrays provide a fixed-size structure for storing homogeneous data, while collections offer greater flexibility for dynamic data. Understanding when to use each type improves code efficiency and readability. By applying these concepts in real-world scenarios, such as storing user input, processing lists, or managing configurations, you can build more robust and scalable applications. Practice implementing arrays and collections in your projects to reinforce your understanding and enhance your programming skills. Error handling and debugging are fundamental concepts in Visual Basic programming that ensure applications run smoothly and efficiently. Error handling refers to the process of anticipating, detecting, and responding to errors that occur during program execution. Debugging, on the other hand, involves identifying and resolving issues in the code that cause unexpected behavior, managing runtime errors, such as invalid input or resource conflicts, and logical flaws, which are mistakes in the program's algorithm, is crucial for creating reliable software. Throughout this session, we will explore techniques to identify and resolve these issues, including structured exception handling, step-by-step debugging, and best practices for maintaining robust code. By the end of this presentation, you will have a clear understanding of how to prevent and address common programming challenges. In Visual Basic, errors can be categorized into three main types: syntax errors, runtime errors, and logical errors. Syntax errors occur when the code violates the language's rules, such as missing semicolons or incorrect keywords. These errors are typically caught by the compiler before the program runs. Runtime errors however, happen during program execution and can cause the application to crash. Examples include division by zero or accessing invalid memory locations. Logical errors are the most challenging to detect because the code runs without crashing but produces incorrect results due to flawed logic, such as an infinite loop or incorrect calculations. Understanding these error types is essential for developing efficient debugging strategies and ensuring the program behaves as intended. Visual Basic provides a powerful mechanism for error handling through the try, catch, finally structure. The try block contains the code that might throw an exception, such as file operations or user input validation. If an error occurs, the program transfers control to the catch block, which handles specific exceptions. For example, a catch block can catch an I/O exception if a file is not found, or a null reference exception if an object is not initialized. This allows developers to respond to errors gracefully instead of letting the program crash. The finally block executes regardless of whether an error occurred, making it ideal for releasing resources like closing files or database connections. By using this structure, you can ensure your applications remain stable even when unexpected issues arise. Debugging is an essential skill for any programmer, and Visual Basic offers several tools to simplify this process. One of the most effective techniques is step-by-step execution, where the program runs line by line, allowing you to observe its behavior. Setting breakpoints is another key method, as it pauses the program at specific lines of code, enabling you to inspect variable values and the flow of execution. The watch window is particularly useful for monitoring the values of variables, expressions, or properties in real time. Additionally, the immediate window allows you to evaluate code snippets or modify variable values during debugging, providing a flexible way to test hypotheses and resolve issues. These tools work together to make debugging more efficient and intuitive. Visual Basic includes built-in debugging tools that enhance the development process. The debugger is the primary tool for tracing execution, allowing you to step through code, set breakpoints, and inspect variables. Breakpoints are markers placed in the code to pause execution, making it easier to analyze the program's state at critical points. The watch window continuously monitors the values of variables, helping you track changes and identify anomalies. The immediate window serves as a command line interface for executing code during debugging, which is invaluable for testing small sections of code or modifying variables on the fly. Together, these tools provide a comprehensive environment for diagnosing and resolving issues in your programs. Adhering to best practices in error handling ensures your code is both robust and maintainable. One key principle is to handle specific exceptions rather than using a generic exception catch-all block. This allows you to address issues more precisely and avoid masking unrelated errors. Logging errors is another critical practice, as it provides a record of what went wrong, which is invaluable for troubleshooting. For example, you can use the event log class to write errors to the system log or save them to a text file for later analysis. Avoiding empty catch blocks is essential, as they can hide errors and make debugging more difficult. Finally, use try catch structures for critical operations like file I/O or database access, where errors can have significant consequences. These practices will help you create more reliable and user-friendly applications. Let's examine real-world scenarios where error handling and debugging techniques are applied. In the first example, division by zero can be prevented using a try catch block. If a user attempts to divide a number by zero, the catch block catches the divide by zero exception and displays a user-friendly message. In the second example, a loop with incorrect logic, such as an infinite loop, can be debugged by setting breakpoints and inspecting variable values in the watch window to identify the flaw. The third example demonstrates logging errors to a file, where each exception is recorded with a timestamp and description, enabling post-execution analysis. These examples illustrate how practical strategies can transform complex problems into manageable tasks, ensuring your applications are both functional and reliable. In conclusion, error handling and debugging are indispensable for developing high-quality Visual Basic applications. By mastering the try catch structure and leveraging debugging tools like breakpoints and the watch window, you can proactively address issues and improve code reliability. Remember that practice is key. Hands-on exercises will reinforce these concepts and help you gain confidence in troubleshooting. As you continue to refine your skills, you'll find that these techniques not only save time, but also enhance the overall user experience. Keep exploring, experimenting, and applying these strategies to create more resilient and efficient programs. Object-oriented programming is a way of organizing code that focuses on objects rather than just functions and procedures. This approach allows programmers to model real-world entities by grouping data and behavior into self-contained units. The key principles include classes, which act as blueprints for creating objects, and objects, which are the actual instances of these classes. Additionally, encapsulation, inheritance, and polymorphism are fundamental concepts that help structure code in a more manageable and reusable way. By using these principles, developers can create modular, scalable, and maintainable programs that are easier to update and expand over time. A class is like a template or blueprint that defines the properties and methods an object can have. For example, if you create a class called car, it might include properties like color and speed, as well as methods like start and stop. An object, on the other hand, is a specific instance of a class. So, when you write dim my car as new car, you are creating a unique car object based on the car class blueprint. This distinction allows programmers to create multiple objects with the same structure but different data, making it easier to manage complex systems. Understanding classes and objects is essential for building structured and efficient code in Visual Basic. Encapsulation is one of the core principles of object-oriented programming, and it involves hiding the internal details of an object while exposing only what is necessary. This is achieved through access modifiers like public, private, and protected. For instance, if a class has a private variable called speed, it cannot be directly modified from outside the class, ensuring data integrity. By restricting access to certain parts of an object, encapsulation helps prevent unintended changes and makes code more secure. This practice also simplifies maintenance, as changes to the internal workings of a class do not affect other parts of the program that use it. Inheritance is a powerful feature that allows a class to inherit properties and methods from another class, creating a hierarchical relationship. The class being inherited from is called the base class or parent class, while the class that inherits is known as the derived class or child class. For example, if you have a base class called car, a derived class like electric car can inherit melodies and methods of CAR, while adding its own unique features. This promotes code reuse and reduces redundancy, as common functionality can be defined once in the base class and shared across multiple derived classes. Inheritance also supports a more organized and logical structure for large programs. Polymorphism is the ability of objects to take on many forms, allowing different classes to be treated as instances of a common parent class. This is often achieved through method overriding, where a derived class provides a specific implementation of a method already defined in its parent class. For example, a base class might have an overridable substart, and a derived class can override this method with its own version. Polymorphism also works with interfaces, which define a contract that classes can implement. This flexibility enables developers to write more generic code that can handle various types of objects, making programs more adaptable and easier to extend. Abstraction is the process of simplifying complex systems by hiding unnecessary details and exposing only essential features. This is commonly achieved through abstract classes and interfaces, which define a set of methods that must be implemented by derived classes. For instance, an abstract class called animal might have a must-override sub-make sound, requiring all derived classes like dog or cat to provide their own implementation. Abstraction helps manage complexity by allowing programmers to focus on what an object does rather than how it does it. This makes code easier to understand, maintain, and modify without needing to know the underlying details. The benefits of object-oriented programming are numerous and significant. Reusability is a major advantage, as classes and objects can be reused across different parts of a program, or even in other projects, saving time and effort. Maintainability is another key benefit, as well-structured code with clear separation of concerns makes debugging and updates more straightforward. Scalability is also enhanced, as OOP allows for the creation of large, complex systems that can grow and evolve over time without becoming unmanageable. By following OOP principles, developers can build robust, efficient, and adaptable software that meets the needs of modern applications. In summary, object-oriented programming forms the foundation of modern software development, offering a structured and efficient way to design and implement programs. Mastering concepts like classes, objects, inheritance, and polymorphism is essential for creating high-quality code that is both reusable and maintainable. As you continue to learn Visual Basic, practicing these principles through real-world examples will help solidify your understanding and improve your ability to solve complex programming problems. By applying OOP techniques, you will be better equipped to build scalable, flexible, and reliable software solutions. A class is a fundamental concept in object-oriented programming that serves as a blueprint for creating objects. Think of it as a template that defines what data and behaviors an object will have. For example, if you're designing a car simulation, a class called car would contain properties like color, speed, and model, as well as methods like accelerate or brake. This structure allows programmers to organize code logically, making it easier to manage and reuse. By encapsulating data and behavior into a single entity, classes promote modularity and maintainability. This approach not only simplifies complex systems, but also ensures consistency across objects created from the same class. An object is essentially an instance of a class, much like how a specific car model is a physical example of a car blueprint. In Visual Basic, you create objects using the new keyword, which allocates memory for the object and initializes its properties. For instance, when you write dim my car as new car, you're creating a unique instance of the car class. Each object can have its own set of values for the properties defined in the class. This means one car might be red and fast, while another is blue and slow. The ability to create multiple independent objects from the same class is a core strength of object-oriented programming, enabling flexible and dynamic applications. Properties are the characteristics that define an object's state, such as color, model, or age. They act as intermediaries between the object's internal data and the outside world, allowing controlled access. For example, a property might be read-only, meaning it can only retrieve data, or write-only, allowing data to be set but not viewed. Most properties, however, are both readable and writable. In Visual Basic, properties use get and set accessors to manage data. The get method returns the value of a private variable, while the set method updates it. This mechanism ensures that data can be validated or modified in a controlled way, preventing invalid states and improving code reliability. Creating a class in Visual Basic is straightforward. You start with the class keyword followed by the class name. For example, public class person defines a class that can be accessed from other parts of the program. Inside the class, you declare properties like name and age, which store the object's data. These properties can be public, making them accessible from outside the class, or private, restricting access. Classes can also include methods, which are functions that perform actions, and events, which respond to user interactions. By structuring code this way, developers can build complex applications by breaking them into manageable, reusable components. Instantiating an object involves using the new keyword to create a specific instance of a class. For example, dim person as new person creates an object named person based on the person class. Once created, you can assign values to its properties, like person, name equals Alice, or person, age equals 30. Each object maintains its own data, so changes to one object do not affect others. This independence is crucial for building applications where multiple instances of the same class need to operate separately. For instance, in a school management system, each student object would have unique details, even though they all come from the student class. Accessing properties is done using dot notation, which is a simple yet powerful way to interact with an object's data. For example, console, write line person, name retrieves the value of the name property and displays it. Properties can also trigger actions when accessed. Imagine a property that checks if a user's age is valid before allowing it to be set. This level of control makes properties more than just storage. They become active components of the object's behavior. By using properties, you can ensure data integrity and add functionality that enhances the object's capabilities. Encapsulation and data hiding are key principles that protect an object's internal state. By declaring variables as private, you restrict direct access, ensuring that they can only be modified through public properties. For example, a private variable age can be accessed via a public age property that includes validation logic. This approach prevents invalid data from being assigned, such as a negative age. Encapsulation also makes code easier to maintain, as changes to the internal implementation do not affect other parts of the program. It's like a secure vault where the key's properties control access to the content's data, ensuring safety and consistency. The benefits of using classes and objects are numerous. Reusability allows you to create code once and use it in multiple projects, saving time and effort. Modularity organizes code into logical units, making it easier to understand and debug. Scalability means applications can grow without becoming unmanageable, as new classes can be added without disrupting existing ones. Maintainability is improved because changes are localized to specific classes, reducing the risk of errors. These advantages make object-oriented programming a preferred choice for developing large, complex systems. For example, a banking application might use classes for accounts, transactions, and users, each handling its own responsibilities. In summary, classes define the structure of objects, which are instances of those classes with their own data. Properties provide controlled access to an object's attributes, ensuring data integrity and flexibility. Object-oriented programming principles like encapsulation, inheritance, and polymorphism form the foundation of modern software development. By organizing code around classes and objects, developers can create applications that are efficient, scalable, and easy to maintain. These concepts are essential for anyone looking to build robust and reusable software solutions in Visual Basic and beyond. Now, let's review the key concepts we've covered. Classes are blueprints for objects, which are instances created using the new keyword. Properties control access to an object's data, and encapsulation protects internal state. We've explored how these elements work together to create organized and efficient code. If you have any questions about the syntax or implementation of these concepts, feel free to ask. Practicing by creating and using classes in Visual Basic will help reinforce your understanding. Let's work through examples together to ensure you're confident in applying these principles. Inheritance is a fundamental concept in object-oriented programming that allows a class to inherit properties and methods from another class. This means that a base class, which is also known as a parent class, can share its code with derived classes, often referred to as child classes. By using inheritance, developers can avoid duplicating code, which promotes code reusability and makes the code base more organized. For example, If you have a base class called animal, you can create a derived class called dog that inherits all the common characteristics of an animal while adding its own unique features. In Visual Basic, this is achieved through the use of the inherits keyword, which specifies that a class is derived from another class. This mechanism not only streamlines development, but also helps in creating a clear hierarchical structure in the code. To create a base and derived class in Visual Basic, you start by defining a base class that contains the common properties and methods that multiple classes might need. For instance, a base class named animal could have properties like name and age, along with a method like speak. A derived class, such as dog, can then use the inherits keyword to extend the animal class. This allows the dog class to access all the members of the animal class, while also adding new functionality or modifying existing methods. For example, the dog class might add a method called bark, or override the speak method to provide a more specific implementation. This approach enables developers to build complex systems by starting with a general base class and then creating specialized derived classes that tailor the behavior to specific needs. Polymorphism is another key principle in object-oriented programming that allows objects of different classes to be treated as objects of a common base class. This flexibility enables code to be written in a way that is more dynamic and adaptable. For instance, if you have a base class called animal and derived classes like dog and cat, you can create a list of animal objects that includes both dog and cat instances. At runtime, the correct method implementation is called based on the actual object type, which is known as runtime polymorphism. Polymorphism can be achieved through method overriding, where a derived class provides a specific implementation of a method defined in the base class. Additionally, compile-time polymorphism, such as method overloading, allows multiple methods with the same name but different parameters to coexist. This capability makes the code more versatile and easier to maintain, as it can handle various types of objects uniformly. Method overriding is a powerful feature in Visual Basic that allows a derived class to provide a specific implementation of a method that is already defined in its base class. To enable this, the base class method must be marked with the overridable keyword, which indicates that it can be overridden. The derived class uses the overrides keyword to replace the base class method with its own version. For example, if the animal class has an overridable method called speak, the dog class can override this method to produce a bark sound instead of a generic animal sound. This ensures that when a method is called on an object, the appropriate implementation is executed based on the object's actual type. Method overriding is essential for achieving runtime polymorphism, as it allows the program to dynamically select the correct method at execution time, enhancing the flexibility and responsiveness of the code. Interfaces play a crucial role in enabling polymorphism by defining a contract that classes must follow. An interface specifies a set of methods, properties, or events that a class must implement without providing any actual implementation. For example, an interface called iShape could define a method called draw, which all classes implementing iShape must provide. This allows different classes, such as circle and square, to have their own unique implementations of the draw method while still being treated as iShape objects. By using interfaces, developers can achieve a high level of abstraction and decoupling in their code, making it easier to modify and extend. Polymorphism via interfaces allows objects to be handled through their interface type, which means that a single method can work with any object that implements the interface. This approach enhances code flexibility and promotes a more modular design. In summary, inheritance and polymorphism are essential tools in visual basic programming that help create scalable and maintainable code. Inheritance allows for code reuse and hierarchical organization, reducing redundancy and improving efficiency. Polymorphism, on the other hand, enhances flexibility by enabling objects to be treated generically, which simplifies complex systems. Combining these concepts allows developers to build robust applications that can adapt to changing requirements. To master these concepts, it is important to practice creating base and derived classes, implementing method overriding, and using interfaces to achieve polymorphic behavior. By applying these principles, you can design software that is not only efficient, but also easy to extend and maintain over time. AduNet is a powerful data access technology designed specifically for net applications. It allows developers to interact with various types of databases, such as SQL Server, Access, and others, core functionality of a DoNet lies in its set of classes that enable you to connect to a database, execute queries, and manipulate data efficiently. These classes include the connection, which establishes a link to the database, the command, which executes SQL statements, the data reader, which provides a fast way to read data, the data adapter, which bridges the gap between the database and the dataset, and the dataset itself, which acts as an in-memory representation of data. Understanding these components is crucial for building robust applications that handle data effectively. To connect to a database in a DoNet, you typically use the SQL connection class when working with SQL Server. This class requires a connection string that contains details like the server name, database name, and authentication information. For example, you might initialize a connection with a string like server equals my server address database equals my database user ID equals my username, password equals my password. Once the connection is established, you can open it using the open method, which prepares the connection for data operations. It is essential to close the connection after use with the close method to free up resources and prevent potential memory leaks or database locks. Properly managing connections ensures your application runs smoothly and efficiently. The SQL command class is used to execute SQL commands against a database. You set the command text property to define the SQL query or stored procedure you want to run. For instance, you might create a command object like dimcmd as new SQL command select from customers, con to retrieve data from a table. The executeReader method is ideal for retrieving data in a forward-only manner, while execute non-query is used for commands that do not return data, such as insert, update, or delete statements. Understanding when to use each method helps optimize your data access strategies and ensures your application performs as expected. The SQL Data Reader provides a fast, forward-only way to read data from a database. Once you execute a command using executeReader, you can iterate through the results using the read method, which moves to the next row in the data. Each row can be accessed by column name or by using the getOrdinal method to retrieve the column index. This approach is particularly useful for scenarios where you need to process large data sets efficiently without loading all the data into memory at once. However, It is important to note that the data reader requires an open connection and does not support navigating backward through the data. The SQL data adapter serves as a bridge between a database and a dataset or data table. It allows you to fill these in-memory structures with data from the database. For example, you can create an adapter with dim adapter as new SQL data adapter ID, and then use the fill method to populate a dataset. This method is versatile because it can also be used to update the database with changes made to the dataset. The adapter relies on underlying command objects to perform insert, update, and delete operations, making it a flexible tool for managing data in both directions. A dataset is an in-memory representation of data that can contain multiple tables, relationships, and constraints. It acts like a mini database, allowing you to work with data without maintaining an open connection to the source. A data table represents a single table within the dataset and provides methods to add, modify, or delete rows. For example, you can use the select method to filter rows based on specific criteria, or create a data view to sort and search data dynamically. These features make the dataset and data table powerful tools for manipulating data in applications that require offline processing or complex data operations. Updating a database using the SQL data adapter involves calling the update method, which sends changes made to the dataset back to the database. For example, adapter update dataset. Table name applies any modifications, inserts, or deletions to the specified table. To ensure this process works correctly, the SQL data adapter must have the appropriate command objects configured for insert, update, and delete operations, handling conflicts, such as when a record has been modified by another user, and using transactions to maintain data integrity are critical steps in this process. These practices help prevent data corruption and ensure reliable updates. Following best practices in a DoNet is essential for building secure and efficient applications. Always close connections and dispose of objects properly to avoid resource leaks. Use parameterized queries to protect against SQL injection attacks, which can compromise your database. Implement try-catch blocks to handle exceptions gracefully and provide meaningful error messages. Additionally, optimize performance by choosing the right data retrieval method, such as using data reader for read-only scenarios, or data adapter for more complex data manipulation. These strategies contribute to a more robust and maintainable application. A DoNet is a fundamental tool for database operations in Visual Basic, offering a comprehensive set of classes to interact with data. By mastering the core components like connection, command, data reader, and data adapter, you can build applications that efficiently retrieve, manipulate, and update data. Real-world practice with examples helps solidify your understanding, while adhering to best practices ensures your code is both secure and efficient. As you continue to explore a DoNet, focus on applying these concepts to practical scenarios to enhance your skills and create reliable solutions. Windows Forms is a graphical user interface framework designed for building desktop applications using the Visual Basic programming language. This framework allows developers to create interactive and visually appealing applications by providing a drag-and-drop interface for designing forms and controls. It serves as the foundational element for user interaction in VBNet applications, enabling users to engage with the software through buttons, text fields, and other visual components. The key components of Windows Forms include forms, which act as the main window for an application, controls that represent individual UI elements, events that respond to user actions, and layout managers that help organize the placement of controls on a form. These elements work together to create a structured and efficient development process for desktop applications. Forms are the primary containers in Windows Forms, acting as the main window or dialog box for an application. They provide a space where controls such as buttons, labels, text boxes, and other UI elements can be placed and managed. Controls are the individual components that users interact with, such as buttons that trigger actions or text boxes that capture input. Events are specific actions, like a button click or a text change, that initiate code execution in response to user interactions. Properties define the characteristics of a control, such as its size, color, or visibility, allowing developers to customize the appearance and behavior of each element. Together, these components form the backbone of any Windows Forms application, enabling the creation of dynamic and responsive user interfaces. To create a simple form, start by opening Visual Studio and selecting a new Windows Forms app project, which sets up the basic structure for a desktop application. Once the project is created, you can drag and drop controls like buttons or text boxes from the toolbox onto the form to build the user interface. The Properties window is essential for modifying control attributes, such as changing the text on a button or adjusting the size of a text box. Finally, you can write code in the form's code behind file, which is the file that contains the logic for the application. For example, double-clicking a button in the designer automatically generates a code block where you can write the code that executes when the button is clicked. This process allows developers to quickly build and customize forms with minimal effort. Events in VBNet are actions that occur when users interact with controls, such as clicking a button or typing in a text box. These events trigger specific code to run, allowing the application to respond dynamically to user input. To handle events, developers can double-click a control in the designer, which automatically generates an event handler method in the code behind file. For instance, a button click event would create a method like private subbutton oneclicksender as object, E as event args. This method contains the code that executes when the button is clicked. Alternatively, developers can use the handles keyword to explicitly link an event to a method, providing greater control over how events are managed. Understanding and implementing event handling is crucial for creating interactive and responsive applications. When designing forms, it is essential to use the designer tool to align and size controls effectively. This tool provides visual aids to help developers position elements precisely on the form. Layout panels, such as Flow Layout Panel and Table Layout Panel, are particularly useful for creating responsive designs that adapt to different screen sizes. Instead of hard-coding positions, developers should rely on anchoring and docking features, which allow controls to adjust their placement automatically when the form is resized. Testing forms on various screen resolutions ensures that the application remains functional and visually consistent across different devices. By following these best practices, developers can create user interfaces that are both user-friendly and adaptable to different environments. Data binding in Windows Forms allows controls to be connected to data sources such as databases or collections, enabling the UI to reflect changes in the underlying data automatically. For example, a text box can be bound to a property of a data object, so any updates to that property are instantly reflected in the text box. This process is achieved using methods like text box one data bindings, add text, data source, property name, which links the controls display to the data source. Data binding supports not only simple data types, but also complex structures like lists and grids, making it a powerful tool for creating dynamic and data-driven applications. By leveraging data binding, developers can reduce the amount of manual code required to update the UI, improving efficiency and maintainability. Windows Forms provides a robust platform for developing rich desktop applications, offering a wide range of tools and features to create interactive and visually appealing interfaces. Mastering event-driven programming and control customization is essential for building applications that respond effectively to user actions. Practicing the design of forms with multiple controls and data binding helps reinforce these concepts and improves overall proficiency. As developers gain experience, they can explore advanced topics such as creating custom controls, implementing animations, and integrating more complex data management techniques. These next steps open up new possibilities for enhancing the functionality and user experience of VBNet applications. Good day. Today, we will explore the world of advanced controls and user interfaces in Visual Basic. These tools are essential for creating applications that are not only functional, but also intuitive and visually appealing. Advanced controls such as Data Grid View, Tab Control, and List View allow developers to organize and present data in ways that are both efficient and user-friendly. For example, a data grid view can dynamically display database records, while a tab control can help users navigate through multiple sections of an application without cluttering the interface. The importance of dynamic and user-friendly interfaces cannot be overstated, as they significantly enhance the user experience, making applications more accessible and easier to interact with. By mastering these controls, you will be able to design interfaces that adapt to user needs, respond to real-time data, and maintain a consistent look across different platforms. Our objectives today include not only understanding these advanced controls, but also improving your UI design skills and learning how to create more engaging user interactions. let's dive into the details. Now, let's discuss how to create custom controls and user controls. In Visual Basic, you can build custom controls by inheriting from existing classes, which allows you to extend their functionality while maintaining their core behavior. For instance, a custom button can be created by inheriting from the button class and adding features like animated hover effects. This approach not only saves time, but also promotes code reusability. User controls, on the other hand, enable modular UI development by allowing you to encapsulate a group of controls into a single, reusable component. Imagine a form that requires a custom data entry panel with specific validation rules. By creating a user control for this panel, you can drag and drop it into multiple forms, ensuring consistency and reducing redundancy. To illustrate, let's walk through the process of designing a custom button with a hover animation. We'll use the mouse center and mouse leave events to adjust the button's appearance, demonstrating how even small customizations can greatly enhance the user experience. Data binding is a powerful technique that connects UI controls to data sources, eliminating the need for manual updates. By binding a control to a dataset, collection, or business object, changes in the data are automatically reflected in the UI, and vice versa. This seamless synchronization is made possible by the binding source component, which acts as an intermediary between the data source and the controls. For example, when you bind a data grid view to a dataset, any modifications to the dataset, such as adding or removing records, are instantly visible in the grid. This not only improves efficiency, but also reduces the risk of errors. Let's take a closer look at how to bind a data grid view to a database. We'll start by creating a dataset, then use the binding source to link the data grid view to the dataset. This process ensures that the UI remains up to date without requiring extensive coding. Additionally, data binding can be applied to other controls, such as text boxes or combo boxes, making it a versatile tool for dynamic applications. Creating responsive and flexible layouts is crucial for ensuring that your application works well on different screen sizes and resolutions. The Flow Layout panel and Table Layout panel are two key tools in Visual Basic for achieving this. The Flow Layout panel arranges controls in a flow, either horizontally or vertically, adjusting their positions as the form resizes. This is ideal for forms that need to adapt to varying content lengths. The table layout panel, on the other hand, organizes controls in a grid-like structure, allowing for precise control over alignment and spacing. For example, a form with multiple input fields can use a table layout panel to ensure that each field is properly aligned, even when the window is resized. In addition to these panels, properties like docking, anchoring, and resizing play a vital role in layout management. Docking allows a control to fill a specific area of the form, while anchoring keeps a control's position relative to the form's edges. By combining these techniques, you can create interfaces that are both visually appealing and functional across different devices. User interface design patterns are essential for organizing complex applications and ensuring maintainability. One of the most widely used patterns is the Model View Controller MVC architecture, which separates an application into three components: the model data and business logic, the view UI, and the controller user input handling. This separation makes it easier to manage changes and reduces the risk of errors. For instance, when a user clicks a button, the controller handles the event, updates the model, and notifies the view to refresh. This approach promotes modularity and scalability, allowing developers to work on different parts of the application independently. Event-driven programming further enhances interactivity by responding to user actions, such as button clicks or form validations. Let's consider a scenario where a form requires validation before submission. By using event handlers, we can check the input fields and display error messages as needed, ensuring a smooth and intuitive user experience. Animations can significantly enhance the user experience by making the interface feel more dynamic and engaging. In Visual Basic, the timer control is a powerful tool for creating animations, such as progress bars, transitions, or fade-in effects. For example, a timer can be used to gradually increase the opacity of a control, creating a smooth fade-in effect. This not only adds visual appeal, but also helps guide the user's attention to specific elements. Transparency and color effects can also be used to highlight important information or indicate state changes. For instance, a button might change color when hovered over, providing immediate feedback to the user. These techniques require careful planning to avoid overwhelming the user. But when used effectively, they can make the application feel more polished and professional. Let's explore how to implement a fade-in animation using the timer control, demonstrating how small changes can have a big impact on the overall user experience. In complex UIs, managing events can become challenging, especially when dealing with nested controls or custom events. Delegates and event handlers provide a structured way to handle these situations. A delegate is a reference to a method that can be passed as a parameter, allowing for flexible event handling. For example, a custom event in a user control can be exposed to the parent form, enabling the form to respond to specific actions. This approach promotes loose coupling between components, making the code more maintainable. Let's take a scenario where a multi-panel interface needs to capture keyboard shortcuts. By using event handlers, we can detect key presses and trigger the appropriate actions, such as saving data or navigating between panels. This level of control ensures that the application remains responsive and efficient, even in complex scenarios. Accessibility and localization are critical for ensuring that your application can be used by a wide range of users. Accessibility features, such as screen reader support and keyboard navigation, make the UI usable for individuals with disabilities. For example, setting the accessible name and accessible description properties of a control can help screen readers provide context to users. Localization, on the other hand, involves adapting the application to different languages and regions. This is typically achieved using resource files, which store text and other content in separate files for each language. For instance, a form can be localized to Spanish and French by replacing the text in the resource files, allowing the application to switch languages dynamically. By implementing these features, you can create applications that are inclusive and adaptable to global audiences. Debugging and testing. UI components are essential for identifying and resolving issues before the application is released. The Visual Basic Debugger allows you to step through code, inspect variables, and set breakpoints to trace the flow of execution. For example, if a data grid view fails to display data, you can use the debugger to check the data source and binding configuration. Testing for responsiveness involves simulating different screen sizes and user interactions to ensure the UI behaves as expected. Edge cases, such as empty data sets or unexpected input, should also be tested to prevent crashes or errors. let's walk through a scenario where a data grid view data binding error occurs. By using the debugger, we can identify the root cause, such as a mismatch between the data source and the control's properties, and apply a fix. This process helps ensure that the application is robust and reliable when developing advanced UIs. Following best practices is crucial for maintaining code quality and user satisfaction. Keeping your code modular and maintainable involves organizing it into reusable components and avoiding tightly coupled logic. For example, separating the UI logic from the business logic using patterns like MVC can make the code easier to manage and update. Prioritizing user feedback means regularly testing the application with real users and incorporating their suggestions to improve the experience. Finally, documenting complex UI logic ensures that other developers can understand and modify the code without confusion. This might include adding comments, creating flowcharts, or writing technical documentation. By adhering to these principles, you can create applications that are not only functional, but also scalable and easy to maintain. To bring everything together, let's examine a case study of building a complex form. Imagine a multi-tab form designed for dynamic data entry, where users can input and manage information across different sections. This form will integrate custom controls, such as a user-defined data entry panel, and leverage data binding to connect the UI to a dataset. The layout will use flow layout panel and table layout panel to ensure responsiveness, with docking and anchoring properties, adjusting the controls as the form resizes. Accessibility features like keyboard navigation and screen reader support will be implemented to make the form usable for all users. Finally, we'll demonstrate how to localize the form for Spanish and French speakers, showing the flexibility of the design. This case study will illustrate how the concepts discussed throughout this presentation can be applied to create a robust and user-friendly application. In conclusion, we've explored advanced controls, user interfaces, and techniques for creating dynamic and user-friendly applications in Visual Basic. From custom controls and data binding to layout management and accessibility, these tools are essential for modern software development. Remember, the key to successful UI design lies in understanding user needs and applying best practices to create intuitive, responsive, and maintainable applications. If you have any questions or need further clarification on any of the topics discussed, please feel free to ask. I'm here to help you implement these concepts in your own projects. Thank you for your attention, and I hope this presentation has provided valuable insights into advanced visual basic programming. Language integrated query is a powerful feature in Visual Basic that allows developers to work with data from multiple sources using a consistent syntax. This technology enables you to query collections, databases, and even XML documents directly within your code. By integrating query capabilities into the language itself, LINQ simplifies the process of retrieving and manipulating data. This reduces the complexity of writing separate query languages and makes your code more readable and maintainable. Whether you are working with in-memory data or external databases, LINQ provides a unified approach that streamlines your development workflow. LINQ offers two primary syntax styles that you can use depending on your needs. The first is query syntax, which resembles SQL and is often easier to read for those familiar with traditional querying. The second is method syntax, which uses a series of method calls and lambda expressions to achieve similar results. Key keywords such as from, where, select, order by, and group by are central to constructing queries. For example, a query might filter items based on a specific condition and then select relevant fields. Additionally, LINQ supports lambda expressions, which are particularly useful for method-based queries and allow for more concise and flexible code. Understanding both syntax styles will enhance your ability to work with different data sources efficiently. LINQ is versatile because it can work with a wide range of data sources. In-memory collections such as arrays, lists, and dictionaries are common targets for LINQ queries, allowing you to process data stored directly in your application. When working with databases, LINQ to SQL or Entity Framework provides a way to interact with relational data using LINQ syntax. For XML data, LINQ to XML offers a robust set of tools to parse, query, and manipulate XML documents. Additionally, LINQ can handle ADUNet datasets and even data from web services, making it a flexible solution for various data integration scenarios. This adaptability makes LINQ an essential tool for developers working with diverse data environments. Let me walk through some practical examples of LINQ queries. Filtering data is a common task, and LINQ makes it straightforward. For instance, you can retrieve customers from a specific country by using a where clause. Sorting data is equally simple, as you can specify the order of results using order by. Aggregation functions like sum, count, and average can be applied to data sets to derive summary information. For example, calculating the total order value for customers becomes efficient with LINQ. Joining data from multiple sources, such as combining customer and order information, is another powerful feature. These examples demonstrate how LINQ simplifies complex data operations and enhances code clarity. The applications of LINQ extend beyond basic querying. It is particularly useful for retrieving filtered data from databases, allowing you to focus on specific subsets of information without writing raw SQL. LINQ also enables you to transform and combine data from multiple sources, such as merging data from a database with XML files or web services. This capability improves code readability by using a unified syntax for different data types. Additionally, LINQ reduces reliance on writing complex SQL queries, which can be error-prone and harder to maintain. By leveraging LINQ, developers can create more efficient and maintainable applications that handle data operations seamlessly. In summary, LINQ provides a unified approach to querying data across various sources, making it a valuable tool for modern applications. Its ability to simplify data manipulation and reduce code complexity enhances productivity and readability. Whether you are working with in-memory collections, databases, or XML, LINQ offers a consistent and powerful solution. As you continue to explore LINQ, practicing with different data sources will deepen your understanding and improve your ability to write efficient queries. Embracing LINQ will not only streamline your development process, but also prepare you for more advanced data-driven applications. Exception handling is a critical concept in programming that allows developers to manage unexpected errors that occur during the execution of a program. These errors, known as exceptions, can disrupt the normal flow of the application and lead to crashes if not properly addressed. By understanding and implementing exception handling, we can ensure that our applications remain stable and user-friendly even when errors occur. Common scenarios where exceptions arise include division by zero, which is mathematically undefined, null references that occur when trying to access an object that hasn't been initialized, and file access issues such as attempting to read from a non-existent file or write to a restricted directory. These situations highlight the necessity of proactive error management to prevent application failures. Exceptions can be categorized into three main types: syntax errors, runtime errors, and logical errors. Syntax errors are detected by the compiler and prevent the program from running. Runtime errors occur during the execution of the program and can be handled using exception handling mechanisms. Logical errors, on the other hand, are not detected by the compiler or runtime environment, but result in incorrect program behavior. When an exception occurs, it propagates through the call stack, meaning it moves from the current method to the calling method, and so on until it is caught or the program terminates. For example, a null reference exception happens when a program attempts to access a member of an object that has not been initialized, leading to a runtime error. Understanding how exceptions propagate helps developers identify and resolve issues efficiently. The try-catch block is a fundamental structure in Visual Basic for handling exceptions. The try block contains the code that might throw an exception, while the catch block captures and handles the exception. The syntax for this structure is try, catch, and try. By using catch X as exception, developers can catch specific exceptions and perform actions such as logging the error or displaying a user-friendly message. For instance, when attempting to open a file that does not exist, a file not found exception is thrown. By wrapping the file access code in a try block and using a catch block to handle the exception, the program can gracefully inform the user and avoid crashing. This approach ensures that the application remains responsive and manageable even in the face of unexpected errors. The finally block is an essential component of exception handling that ensures specific code is executed regardless of whether an exception occurs. This is particularly useful for releasing resources such as file streams, database connections, or network sockets that might otherwise remain locked. For example, after opening a file, the finally block can be used to close the file stream, even if an exception is thrown during the file operations. This guarantees that resources are properly released, preventing memory leaks and other issues. The finally block is always executed, making it a reliable way to perform cleanup tasks and maintain the integrity of the application. Logging mechanisms play a vital role in debugging and monitoring applications. By recording detailed information about runtime events, this information can help developers identify the root cause of issues and track the behavior of the application over time. Common tools for logging include the Windows Event Viewer, which provides a centralized location for system and application logs, text files that can be manually inspected, and third-party libraries like nlog or log4net for more advanced logging capabilities. In Visual Basic, developers can use system diagnostics, debug, write line to output debug information, or implement custom logging solutions such as LogWriter. Effective logging ensures that even if an exception is handled, the details are preserved for future analysis, aiding in the maintenance and improvement of the application. Adhering to best practices in exception handling is crucial for creating robust and maintainable applications. One key practice is to avoid empty catch blocks, which can silently ignore errors and make debugging difficult. Instead, exceptions should be logged or handled in a way that provides meaningful feedback to the user or developer. Another important guideline is to use specific exception types rather than catching the general exception class. This allows for more precise error handling and prevents unintended side effects. Combining try-catch-finally blocks ensures that errors are managed effectively, while resources are properly released. By following these best practices, developers can create applications that are not only stable, but also easier to debug and maintain over time. In summary, exception handling is a vital technique for preventing application crashes and ensuring a smooth user experience. By anticipating and managing errors, developers can build applications that remain functional even in unexpected scenarios. Logging mechanisms provide valuable insights into runtime issues, enabling continuous improvement and troubleshooting. Applying these techniques in Visual Basic programming allows for the creation of reliable, maintainable, and user-friendly applications. As you continue your journey in programming, remember that effective exception handling is not just a technical skill, but a fundamental aspect of delivering high-quality software. Collections are data structures designed to store and manage groups of objects, making it easier to handle multiple items in a program. They provide a way to organize, access, and manipulate data efficiently. Generics take this a step further by allowing developers to create type-safe and reusable code. Instead of working with generic objects, you can define classes, methods, or interfaces that operate on specific types, such as integers or strings. This approach ensures that the code is more robust, as it reduces the risk of runtime errors and improves clarity. By understanding collections and generics, programmers can write more efficient, maintainable, and scalable applications, which is essential for modern software development. In Visual Basic, several types of collections are available to suit different needs. The array list is a dynamic array that can hold a variety of object types, making it flexible for scenarios where the data type might change. However, this flexibility comes with the trade-off of needing to cast objects when retrieving them. The list of T, or list of T, is a type-safe collection that stores homogeneous data, ensuring that all elements are of the same type. This eliminates the need for casting and improves code reliability. The dictionary of T-key and T-value is ideal for storing key-value pairs, allowing for fast lookups based on a unique key. Meanwhile, the queue of T and stack of T follow FIFO and LIFO principles, respectively, making them suitable for tasks like task scheduling or undo functionality. Each of these collections has its own strengths and use cases, and choosing the right one can significantly enhance program performance. Generics are a powerful feature that enables developers to define classes, methods, or interfaces with placeholder types. For example, a list of integer is a generic collection where the placeholder T is replaced with the specific type integer. This approach ensures that the collection only contains elements of the specified type, which eliminates the need for explicit casting. By avoiding casting, generics reduce the likelihood of runtime errors, such as invalid type conversions. Additionally, generics improve performance by preventing the overhead of boxing and unboxing value types. This is particularly beneficial when working with large datasets or performance-critical applications. Overall, generics provide a safer, more efficient and more flexible way to write reusable code in Visual Basic. The key differences between traditional collections and generics lie in type safety, performance, and flexibility. Traditional collections, such as ArrayList, are non-type safe, meaning they can store any object type. This flexibility can lead to runtime errors if the wrong type is accessed. These collections also require casting when retrieving elements, which can be error-prone and inefficient. In contrast, generics are type-safe, ensuring that only the specified type of elements is stored and retrieved. This eliminates the need for casting and reduces runtime errors. Generics also offer better performance, especially for value types, as they avoid the overhead of boxing and unboxing. Furthermore, generics provide greater flexibility by allowing developers to create reusable code that works with a variety of data types without sacrificing type safety. Working with List of T in Visual Basic is straightforward and efficient. To create a list, you can use the syntax dim numbers as new list of integer, which initializes an empty list that will hold integers. Adding items to the list is simple with the add method, such as numbers, add 10. Iterating through the list is done using a for each loop, which allows you to process each element sequentially. List of T also provides a range of built-in methods for manipulating data, such as sort to arrange elements in order, find to locate a specific item, and remove to delete an element. These methods make it easy to perform common operations without writing complex code. By leveraging List of T, developers can efficiently manage dynamic arrays while ensuring type safety and reducing errors. The dictionary of T-key and T-value is a collection that stores data in key-value pairs, making it ideal for scenarios where quick lookups are required. To create a dictionary, you might use dim studentages as new dictionary of string, integer, which defines a dictionary that maps strings such as student names to integers like ages. Adding entries is done with the add method, such as student ages. Add John, 20. Accessing values is straightforward using the key, as in student ages John, which retrieves the age associated with the key John. However, it is important to check if a key exists before accessing it, which can be done with the contains key method. This ensures that your code does not throw an exception if the key is not present. Dictionaries are particularly useful for tasks like maintaining a phone book or a lookup table, where data is retrieved based on a unique identifier. Practical examples illustrate the power of collections and generics in real-world scenarios. For instance, storing and sorting a list of strings can be achieved by creating a list of string, adding items, and then using the sort method to arrange them alphabetically. Another example involves using a dictionary to map student IDs to names, allowing for efficient retrieval of student information based on the ID. Combining collections with LI and Q further enhances their capabilities, enabling complex queries to filter, sort, or transform data. For example, you might use LI and Q to find all students older than a certain age, or to count the number of entries in a dictionary. These examples demonstrate how collections and generics can be used to solve common programming problems while maintaining code clarity and efficiency. Following best practices when working with collections and generics can greatly improve code quality and maintainability. It is recommended to prefer generics over non-generic collections whenever possible, as they provide type safety and reduce errors. For dynamic arrays, the list of T is the preferred choice due to its flexibility and performance. Avoiding unnecessary casting by leveraging type parameters ensures that your code remains clean and efficient. Additionally, selecting the appropriate collection based on the task at hand, such as using a queue for FIFO operations or a stack for LIFO scenarios, can optimize performance. By adhering to these practices, developers can write more reliable, scalable, and maintainable applications that meet the demands of modern software development. Collections and generics are fundamental concepts in Visual Basic programming, offering essential tools for managing data effectively. Generics, in particular, provide a safer and more efficient alternative to traditional collections by ensuring type safety and reducing runtime errors. Their ability to create reusable code and improve performance makes them a cornerstone of modern application development. By applying these concepts, developers can build scalable, maintainable, and robust applications that handle data with precision and efficiency. Whether working with lists, dictionaries, or other collection types, understanding and utilizing generics and collections is crucial for success in Visual Basic programming. Delegates, events, and callbacks are fundamental concepts in Visual Basic programming that enable flexible and dynamic interactions within applications. Delegates act as type-safe function pointers, allowing methods to be referenced and invoked dynamically. This capability is crucial for scenarios where you need to pass methods as parameters or execute them at a later time. Events, on the other hand, provide a structured way for classes to communicate changes to other objects, such as when a user clicks a button or data is updated. Callbacks further enhance this by allowing functions to be passed into other methods, which can then be executed at a specific moment, often in asynchronous operations. Together, these elements form the backbone of modular and event-driven programming, making code more reusable, maintainable, and responsive to user interactions. To understand delegates, it's important to recognize that they define a specific method signature, which means they specify the return type and parameters a method must have. This ensures type safety, preventing errors that might occur with less structured approaches. For example, a delegate might be declared to accept an integer value and return no result. As in the syntax public delegate sub my delegate by val value as integer, this allows developers to pass methods that match this signature to other parts of the program. Delegates are particularly useful for dynamic method invocation, where the exact method to execute is determined at runtime. They also play a key role in event handling, as events are essentially encapsulated delegates that notify other components when specific actions occur. By using delegates, developers can create more adaptable and decoupled code structures. Events take the concept of delegates a step further by providing a mechanism for classes to notify other objects of changes or specific actions. Unlike regular delegates, events are designed to be triggered by the class that defines them, while other classes can subscribe to these notifications. For instance, a button click in a graphical user interface might trigger an event that executes a specific method. The syntax for declaring an event includes parameters such as the sender object and event arguments, as seen in public event, my event by val sender as object, by val e as event args. To manage these notifications, developers use add handler and remove handler to subscribe or unsubscribe from events, ensuring that the appropriate methods are called when the event occurs. This encapsulation of delegates into events promotes a clean separation of concerns, allowing components to interact without direct dependencies. Callbacks are functions that are passed as parameters to another method, enabling asynchronous or deferred execution. This is particularly useful in scenarios where a task might take time to complete, such as loading data from a file or processing a large data set. For example, the method process data might accept a callback function that is executed once the data processing is finished. This approach allows the program to continue running other tasks while waiting for the operation to complete, improving efficiency and responsiveness. In Visual Basic, callbacks can be implemented using delegates or lambda expressions, providing flexibility in how they are defined and used. By leveraging callbacks, developers can create more efficient and scalable applications, especially in environments where user interaction or external data sources are involved. While delegates, events, and callbacks are related, they serve distinct purposes in program flow. Delegates act as references to methods, allowing them to be passed around and invoked dynamically. Events are a specialized form of delegates designed for notifications, ensuring that only the appropriate methods are called when specific actions occur. Callbacks, in contrast, are functions that are executed after a task completes, often to handle results or perform follow-up actions. Understanding these differences is essential for designing efficient and maintainable code. Delegates provide the foundation for both events and callbacks, while events and callbacks build on this foundation to handle specific use cases. By mastering these concepts, developers can create more modular and responsive applications that adapt to changing requirements and user interactions. In practical applications, delegates, events, and callbacks are used to solve real-world programming challenges. Delegates are often employed to implement custom sorting or filtering logic, where the exact behavior can be determined at runtime. For example, a delegate might be used to define a comparison function for sorting a list of objects. Events are essential for handling user interactions, such as button clicks or form submissions, allowing the application to respond dynamically to user input. Callbacks, meanwhile, are critical in asynchronous operations, such as loading data from a database or processing files in the background. When combined, these concepts enable the creation of highly responsive and modular code, where different components can communicate and interact without being tightly coupled. This approach not only improves code organization, but also enhances scalability and maintainability. In conclusion, delegates, events, and callbacks are essential tools for any Visual Basic developer aiming to build flexible and efficient applications. Delegates provide the foundation for dynamic method invocation, allowing for greater code reusability and adaptability. Events enable decoupled communication between components, making it easier to manage complex interactions without direct dependencies. Callbacks improve efficiency in asynchronous tasks, ensuring that applications remain responsive even during long-running operations. By mastering these concepts, developers can create more modular, scalable, and maintainable code that meets the demands of modern software development. Whether working on user interfaces, data processing, or network interactions, these principles form the backbone of effective VBNet programming. Multi-threading is a powerful technique that allows a single program to execute multiple threads simultaneously. This means different parts of a program can run at the same time, which is especially useful for tasks that require handling multiple operations concurrently. By leveraging multiple CPU cores, multi-threading can significantly improve performance, making applications faster and more efficient. Key concepts in this area include threads, which are the smallest units of execution within a process, processes, which are independent programs running in the system, and synchronization, which ensures that threads work together without conflicts. The Net framework provides a robust set of tools, such as the system threading namespace, to manage threads effectively. This namespace includes classes like thread, mutex, and monitor, which help developers control thread behavior and prevent issues like race conditions. Asynchronous programming is essential for creating responsive applications, especially when dealing with long-running tasks that could otherwise freeze the user interface. By using the async and await keywords in VBNet, developers can write non-blocking code that allows the application to remain interactive while performing background operations. The task and task of T-types are fundamental to this approach, representing asynchronous operations that can be awaited. For example, an async submethod like loadDataSync can handle I/O-bound tasks, such as reading from a file or fetching data from a web service without halting the main thread. This not only improves user experience, but also optimizes resource usage by freeing up the main thread to handle other tasks. Asynchronous programming is particularly beneficial for I/O-bound operations, where waiting for external resources is common. The benefits of multi-threading are numerous and can greatly enhance the performance and usability of applications. One of the most significant advantages is improved application responsiveness, as multi-threading allows the user interface to stay active while background processes run. This is critical for applications that need to handle multiple tasks simultaneously, such as a media player that streams video while allowing user interactions. Efficient resource utilization is another key benefit, as multi-threading ensures that CPU and memory are used optimally, preventing idle time that could otherwise waste computational power. Parallel processing enables tasks to be divided into smaller chunks, which can be executed simultaneously, speeding up overall execution. Finally, multi-threading supports scalability, allowing applications to handle increasing workloads by distributing tasks across multiple threads or processes. While multi-threading offers many advantages, it also presents several challenges that developers must carefully manage. Race conditions occur when multiple threads access shared data simultaneously, leading to unpredictable results. For instance, if two threads try to update the same variable at the same time, the final value may be incorrect. Deadlocks and thread starvation are other critical issues. A deadlock happens when two or more threads are waiting for each other to release resources, causing them to be stuck indefinitely. Thread starvation occurs when a thread is unable to get the resources it needs to execute, often due to other threads monopolizing the system. Debugging and testing multi-threaded applications can be complex because the order of thread execution is non-deterministic, making it difficult to reproduce and fix issues. Additionally, the overhead of creating and switching between threads can sometimes outweigh the benefits, especially for short-lived tasks. Implementing multi-threading in VBNet involves using the thread class from the system threading namespace, which allows developers to create and manage individual threads. For example, a new thread can be initialized with a method that it will execute, and then started using the start method. This approach is useful for tasks that require direct control over thread behavior. However, for applications that need to update the user interface during long-running operations, the background worker component is a more suitable choice. It provides a simple way to run tasks on a separate thread and report progress back to the UI thread. Thread pooling is another technique that optimizes performance by reusing a pool of threads to handle multiple tasks, reducing the overhead of creating and destroying threads repeatedly. This is particularly effective for applications that require handling many short-lived tasks efficiently. Asynchronous programming in VBNet relies on the async and await keywords, which simplify the management of non-blocking operations. When a method is marked as async, it returns a task or task of T, which represents the ongoing operation. The await keyword is used to pause the execution of the method until the task completes, allowing the thread to be used for other tasks in the meantime. For example, a method like SumAsync method might return a task of integer, and using await with it allows the program to wait for the result without blocking the main thread. For CPU-bound operations, such as complex calculations, the task run method can be used to offload work to a separate thread, preventing the UI thread from becoming unresponsive. This approach ensures that the application remains responsive while efficiently utilizing system resources. Adhering to best practices is crucial when working with multi-threading to avoid common pitfalls and ensure reliable code. One of the most important practices is to avoid sharing state between threads without proper synchronization. Shared data can lead to race conditions, so using mechanisms like synclock or mutex can ensure that only one thread accesses the data at a time. For I/O-bound tasks, the async and await model is preferable to traditional threading because it reduces the overhead of managing threads. Minimizing the use of thread sleep is also important, as it can waste CPU resources and make the application less efficient. Instead, developers should use asynchronous methods or timers to handle delays. By following these practices, developers can create robust, scalable applications that handle concurrency safely and efficiently. In conclusion, multi-threading and asynchronous programming are essential techniques for building high-performance applications. These approaches enable applications to handle complex tasks while maintaining responsiveness and efficient resource usage. However, they require careful design and implementation to avoid issues like race conditions, deadlocks, and debugging challenges. VBNet provides a rich set of tools, including the system, threading namespace, and the async await model to support both multi-threading and asynchronous programming. By understanding the principles and best practices discussed, developers can harness these techniques to create scalable, reliable, and user-friendly applications. Real-world scenarios, such as handling user input while performing background processing or managing multiple I/O operations, offer valuable opportunities to practice and master these concepts. Design patterns are like blueprints that provide proven solutions to common challenges in software development. They act as a shared language for developers, ensuring that complex problems are approached with consistency. In Visual Basic, these patterns help structure code in a way that is easier to maintain, scale, and understand. By leveraging design patterns, you can avoid reinventing the wheel and focus on solving unique business problems rather than generic ones. The importance of design patterns lies in their ability to streamline development processes. They reduce redundancy by offering reusable solutions, which means less code to write and maintain. When teams use design patterns, they can communicate more efficiently, as terms like singleton or observer carry specific meanings. Additionally, these patterns help manage the complexity of modern applications by breaking down large systems into manageable, interconnected components. In Visual Basic, several design patterns are particularly useful. The singleton pattern ensures a single instance of a class, which is ideal for managing shared resources. The factory pattern centralizes object creation, making your code more flexible. The observer pattern enables objects to notify others of changes, which aligns well with VB's event-driven model. The strategy pattern allows dynamic behavior changes, while the command pattern supports undo functionality. Finally, the repository pattern separates data access logic, enhancing testability. Each of these patterns is tailored to VB's strengths, such as its object-oriented features and event handling. The singleton pattern is a powerful tool for ensuring that a class has only one instance. This is particularly useful in scenarios where a single point of control is needed, such as managing application-wide settings or a database connection. In Visual Basic, this is achieved by making the constructor private and providing a shared static method to access the instance. However, it's important to use this pattern judiciously, as overuse can lead to tightly coupled code. The factory pattern simplifies object creation by encapsulating the logic for generating instances of related classes. For example, a shape factory might return either a circle or a square based on input parameters. This decouples your code from specific class dependencies, making it easier to modify or extend the system. In Visual Basic, the factory pattern can be implemented using shared methods or factory classes, allowing for greater flexibility in how objects are instantiated. The observer pattern establishes a one-to-many relationship between objects, where changes in one object trigger updates in others. This is ideal for scenarios like real-time data updates or event-driven systems. In Visual Basic, events and delegates are natural fits for implementing this pattern. For instance, a stock price observer could notify multiple UI elements whenever the price changes, ensuring all relevant parts of the application stay synchronized. The strategy pattern allows you to define a family of algorithms, encapsulate each one, and make them interchangeable. This is useful when you need to switch between different behaviors at runtime, such as choosing between various payment methods. In Visual Basic, this can be achieved through interfaces or abstract classes, with concrete implementations handling specific logic. By using the strategy pattern, you can keep your code modular and adaptable to changing requirements. The command pattern turns requests into objects, enabling operations like undoing or redoing actions. This is particularly useful in applications that require transactional behavior or queued tasks. In Visual Basic, delegates and events can be used to encapsulate commands, making it easier to manage complex workflows. For example, a text editor might use the command pattern to support undo functionality by storing each action as a command object. The repository pattern abstracts the logic for accessing data sources, such as databases or APIs, separating it from business logic. This improves testability and makes your code more maintainable. For instance, a product repository might handle all interactions with a database, allowing the rest of the application to work within memory objects. In Visual Basic, this pattern helps create a clear separation of concerns, making it easier to swap out data sources without affecting the core application. Design patterns bring numerous benefits to Visual Basic projects. They organize code into logical structures, making it easier to navigate and modify. By reusing established solutions, you reduce the risk of errors and speed up development. Patterns also simplify complex systems by breaking them into smaller, manageable parts. This leads to applications that are not only scalable, but also easier to maintain over time, even as requirements evolve. While design patterns are powerful, they are not a one-size-fits-all solution. Overusing them can introduce unnecessary complexity, making code harder to understand. It's crucial to understand both the pattern and the problem it solves before applying it. Additionally, VB's dynamic typing and event-driven model may require adjustments when implementing certain patterns. For example, the factory pattern might need to handle late-bound objects differently than in statically typed languages. When applying design patterns in Visual Basic, focus on solving real problems rather than forcing patterns into every scenario. Prioritize code readability, as clarity often outweighs strict adherence to a pattern. Combining patterns can also be effective. For instance, using a factory to create strategy objects allows for flexible algorithm selection. The key is to balance pattern usage with the specific needs of your project, ensuring that the solution is both efficient and maintainable. A real-world example of design patterns in action involves a stock tracking application. The observer pattern could be used to notify users of price changes in real time. The factory pattern might generate different report types, such as PDF or Excel, based on user preferences. Meanwhile, the repository pattern would handle data retrieval from a database, keeping the business logic separate from the persistence layer. Together, these patterns create a robust, scalable application. Design patterns are essential tools for building structured and efficient Visual Basic applications. They provide solutions to recurring design challenges, allowing developers to focus on higher-level problems. However, mastering these patterns requires practice and a deep understanding of VB's unique features. By studying and applying them thoughtfully, you can create code that is not only functional, but also elegant and maintainable. In conclusion, design patterns significantly enhance the quality and productivity of Visual Basic development. They offer a strategic approach to solving complex problems while maintaining flexibility. By applying patterns thoughtfully and continuously refining your understanding, you can build applications that are both powerful and easy to maintain. Embrace these techniques, and you'll see a marked improvement in your VB programming skills. Performance optimization in Visual Basic refers to the process of improving the efficiency and speed of your code to ensure it runs as smoothly and quickly as possible. This is crucial because inefficient code can lead to slow applications, which negatively impact user experience. Users expect applications to respond quickly and use system resources wisely. By focusing on performance optimization, you not only enhance the speed of your application, but also reduce the strain on hardware, making it more scalable and reliable. Key techniques include identifying and eliminating inefficiencies, using the right algorithms, and leveraging the capabilities of the Visual Basic language and Net framework. Minimizing redundant code is a fundamental step in optimizing Visual Basic applications. Repeated calculations within loops can significantly slow down your program, especially if the loop runs many times. For example, if you calculate the same value multiple times in a loop, storing it in a variable instead can save processing time. Using constants instead of hard-coding values makes your code more maintainable and reduces the risk of errors. Constants also allow for easier updates if the value needs to change later. Additionally, built-in functions in Visual Basic are often optimized for performance, so relying on them instead of writing custom code can lead to faster execution. Always check the documentation to ensure you're using the most efficient methods available. Efficient data handling is essential for maintaining optimal performance in Visual Basic. Choosing the correct data types, such as using integer instead of object, can reduce memory usage and improve processing speed. For instance, an integer requires less memory and is faster to manipulate than an object, which is a more complex type. Avoiding unnecessary conversions between data types is also critical, as these conversions can introduce overhead and potential errors. When working with databases, optimizing queries by using parameters and indexes ensures that data retrieval is as fast as possible. Parameters prevent SQL injection and allow the database to cache query plans, while indexes speed up search operations by creating a structured reference to your data. Optimizing loops and conditional logic can dramatically improve the performance of your Visual Basic applications. Nested loops, especially those with large iterations, can lead to exponential increases in processing time. Whenever possible, restructure your code to reduce the number of nested loops, or replace them with more efficient algorithms. Early exits, such as using exit for or exit if statements, help avoid unnecessary iterations once a condition is met. For example, if you're searching for a specific item in a list, exiting the loop as soon as the item is found saves time. Simplifying complex conditionals by breaking them into smaller, more manageable parts can also improve readability and execution speed. Sometimes, using logical operators like and also or else can optimize the evaluation of conditions. Proper memory management is vital to prevent your visual basic applications from consuming excessive resources. Unneeded objects, such as those that hold references to files, databases, or other system resources, should be released using the dispose method. Failing to do so can lead to memory leaks, where the application continues to use memory even after the objects are no longer needed. Managing references carefully, such as setting objects to nothing when they are no longer required, helps the garbage collector reclaim memory more efficiently. Using blocks ensures that disposable resources are automatically released, even if an exception occurs during their use. This practice is especially important for objects that implement the iDisposable interface, such as file streams or database connections. Reducing I/O operations is a key strategy for improving application performance, particularly in scenarios involving file or database access. Instead of performing individual I/O operations, batch them together to minimize the overhead of multiple calls. For example, inserting multiple records into a database at once is more efficient than inserting them one by one. Asynchronous methods, such as async and await, allow your application to remain responsive while waiting for I/O tasks to complete, preventing the user interface from freezing. Caching frequently accessed data, such as configuration settings or query results, can also reduce the need for repeated I/O operations. However, be cautious about cache size and expiration to avoid using excessive memory. Leveraging built-in libraries and frameworks in Visual Basic can save time and improve performance. The Net framework provides a wide range of optimized methods for common tasks, such as string manipulation, data processing, and network communication. Using these pre-built functions instead of writing custom code, reduces the likelihood of bugs and ensures that your code benefits from the optimizations implemented by the framework. LINQ language integrated query is a powerful tool for querying data in a concise and readable way. It allows you to work with collections, databases, and other data sources using a unified syntax, which is both efficient and easy to maintain. Always consider the trade-offs between using built-in functions and custom solutions, but prioritize the former when possible. Profiling and debugging tools are indispensable for identifying and resolving performance issues in Visual Basic applications. The Visual Studio Performance Profiler provides detailed insights into how your code executes, highlighting areas where time is spent or resources are consumed. By using breakpoints and logging, you can trace the flow of your application and pinpoint bottlenecks. Monitoring memory usage and CPU utilization helps you understand how your application interacts with the system and detect potential inefficiencies. For example, a sudden spike in memory usage might indicate a memory leak, while high CPU usage could suggest an algorithm that needs optimization. Regularly using these tools during development ensures that your application remains efficient and scalable. Adhering to best practices for optimization ensures that your Visual Basic code is both efficient and maintainable. Writing clean, readable code makes it easier to identify and fix performance issues later. While micro-optimizations can be tempting, prioritizing readability and simplicity often leads to better long-term results. For instance, a well-structured loop is easier to optimize than a tangled mess of nested conditions. Testing your changes with real-world scenarios is essential to ensure that optimizations actually improve performance in practical situations. This might involve simulating high user loads, testing with large datasets, or using profiling tools to measure the impact of your changes. Remember that the goal is not just to make your code faster, but to make it reliable and easy to work with. Performance optimization is a critical aspect of developing high-quality Visual Basic applications. It enhances user satisfaction by ensuring that your software runs smoothly and efficiently. By focusing on reducing redundancy, managing resources effectively, and utilizing the right tools, you can create applications that are both fast and scalable. However, it's important to to strike a balance between efficiency and maintainability. Code that is overly optimized for speed, but difficult to understand, can become a maintenance nightmare. Always consider the long-term impact of your optimizations and strive for a solution that is both performant and easy to work with. With these principles in mind, you can build applications that meet the needs of users while standing the test of time. Security in software development is a critical aspect that ensures the protection of data, systems, and user trust. Without proper security measures, applications can become vulnerable to a wide range of threats, including unauthorized access, data breaches, and malicious attacks. Common vulnerabilities in Visual Basic applications often stem from issues such as improper input handling, weak authentication mechanisms, and insecure data storage. For example, unvalidated user inputs can lead to injection attacks, while poor encryption practices may expose sensitive information. To mitigate these risks, developers must adopt key security best practices. This includes implementing robust validation, encrypting sensitive data, and following secure coding standards. By prioritizing security at every stage of the development process, we can create applications that are not only functional, but also resilient against potential threats. Validating all user inputs is a fundamental step in preventing injection attacks, which occur when malicious data is inserted into an application to exploit vulnerabilities. For instance, SQL injection can compromise databases by executing unauthorized commands. To counter this, developers should leverage net built-in validation classes such as regex for pattern matching and string validator for checking input formats. These tools help ensure that user inputs adhere to expected constraints. Additionally, dynamic SQL queries should be avoided in favor of parameterized queries, which separate data from commands and reduce the risk of code injection. By enforcing strict input validation and using secure query methods, developers can significantly enhance the security of their Visual Basic applications. Secure data handling involves protecting sensitive information both at rest and in transit. Encrypting data such as passwords and connection strings is essential to prevent unauthorized access. For example, using encryption algorithms like AES ensures that even if data is intercepted, it remains unreadable without the correct decryption key. Visual Basic developers can utilize secure storage mechanisms, such as the Windows Data Protection API, which provides a layer of encryption for sensitive data. It is also crucial to minimize the exposure of sensitive information in logs or error messages. Logging detailed error information can inadvertently reveal system vulnerabilities to attackers. By implementing encryption and careful logging practices, developers can safeguard critical data and reduce the risk of data breaches. Authentication and authorization are vital for controlling access to application resources. Implementing strong authentication mechanisms, such as Windows authentication, ensures that only verified users can access the system. Role-based access control (RBAC) further enhances security by assigning permissions based on user roles, limiting access to necessary functions. For example, an administrator might have different privileges compared to a regular user. Hard-coding credentials in code or configuration files is a significant security risk, as it exposes sensitive information if the code is compromised. Instead, developers should use secure methods to store and retrieve credentials, such as encrypted configuration files or secure credential managers. By enforcing robust authentication and authorization processes, applications can prevent unauthorized access and protect critical operations. Structured error handling is essential for maintaining application stability and security. Using try-catch blocks allows developers to gracefully handle exceptions and prevent unexpected crashes. However, it is equally important to log errors securely without exposing sensitive details. For example, instead of displaying raw database error messages to users, applications should provide generic messages that do not reveal system-specific information. This prevents attackers from exploiting known vulnerabilities. Additionally, avoiding generic error messages helps maintain user trust by ensuring that the application does not inadvertently disclose internal workings. By combining effective error handling with secure logging practices, developers can create more resilient and secure applications. Secure communication is critical for protecting data transmitted over networks. For web-based Visual Basic applications, using HTTPS ensures that data is encrypted during transit, preventing eavesdropping and man-in-the-middle attacks. This is achieved through protocols like TLS and SSL, which establish secure connections between clients and servers. Validating SSL certificates is another essential step, as it confirms the authenticity of the server and prevents connections to malicious entities. Developers should also ensure that their applications enforce secure communication by rejecting unencrypted connections. By implementing these measures, developers can safeguard data integrity and confidentiality, especially when handling sensitive user information. Code security practices involve maintaining the integrity and reliability of the application's source code. Regularly updating dependencies and frameworks is crucial, as outdated libraries may contain known vulnerabilities that can be exploited. Developers should also avoid using deprecated or insecure VB functions, which may lack modern security features. For example, functions that handle string manipulation or file operations should be replaced with safer alternatives. Additionally, performing code reviews allows teams to identify and address potential security flaws before they reach production. By fostering a culture of continuous improvement and collaboration, developers can proactively strengthen the security of their Visual Basic applications. Secure configuration management ensures that application settings are handled with the same level of care as code. Storing configuration settings in secure locations, such as encrypted files or secure vaults, prevents unauthorized access to sensitive data like API keys or database credentials. Developers should also use environment-specific settings to manage different deployment stages, such as development, testing, and production, ensuring that configurations are tailored to each environment. Restricting file and directory permissions further limits access to sensitive data, reducing the risk of accidental or intentional misuse. By implementing these practices, developers can maintain a secure and controlled configuration environment. Prioritizing security throughout the entire development lifecycle is essential for creating reliable and trustworthy applications. From the initial design phase to deployment and maintenance, security considerations should be integrated into every step. Following standardized practices for input validation, encryption, and access control ensures that applications are built with security in mind. Additionally, staying updated on emerging security threats and mitigation strategies helps developers adapt to evolving challenges. By fostering a proactive approach to security, developers can protect their applications, users, and the broader ecosystem from potential risks. Remember, security is not a one-time task, but an ongoing commitment to continuous improvement and vigilance. Packaging and deployment are fundamental aspects of software development that ensure applications reach end users efficiently and reliably. Packaging involves gathering all necessary components of an application, such as executable files, libraries, configuration files, and resources into a single, manageable unit. Deployment, on the other hand, refers to the process of delivering this packaged application to the target environment, whether it be a local machine, a network, or a cloud platform. Effective deployment strategies are critical because they determine how seamlessly users can access and interact with the software. A well-planned strategy ensures that the application is not only delivered, but also functions correctly in the user's environment. The primary goals of deployment include reliability, which means the application must perform consistently without failures. Scalability, allowing it to handle growth in users or data. And user accessibility, ensuring that the software is easy to install, update, and use across different devices and platforms. Understanding the key concepts of packaging and deployment is essential for any developer. Packaging is the process of bundling an application's files, dependencies, and resources into a structured format that can be distributed. This includes ensuring that all required libraries, such as dynamic link libraries or frameworks, are included to prevent runtime errors. Deployment is the act of delivering this packaged application to the end user, which can take various forms. Deployment types include local deployment, where the application is installed directly on a user's machine. Network deployment, which involves distributing the application across a local area network. Cloud deployment, leveraging remote servers for hosting and accessibility. And automated deployment, which uses scripts or tools to streamline the process. Tools like Visual Studio provide built-in support for packaging and deployment, offering features such as click once for easy distribution, MSI files for traditional installation, and web deployment for hosting applications online. Each tool has its own advantages and use cases, and selecting the right one depends on the application's requirements and the target audience. Click Once deployment is a method developed by Microsoft specifically for Windows applications. It allows developers to publish applications that users can install and update with minimal effort. One of the key benefits of Click Once is its ability to handle updates automatically, ensuring users always have the latest version without manual intervention. This is particularly useful for applications that require frequent bug fixes or feature enhancements. Another advantage is the sandboxed environment, which isolates the application from the host system, reducing the risk of conflicts or security vulnerabilities. To use Click Once, developers first publish their project through Visual Studio, configuring deployment settings such as update frequency, installation location, and security permissions. Once configured, the application can be distributed via a web server, file share, or local network. This method is ideal for applications that need to be deployed to a large number of users quickly and efficiently. MSI, or Windows Installer, is a traditional deployment method that uses MSI files to install applications on Windows systems. Unlike Click Once, MSI provides greater control over the installation process, allowing developers to customize the setup experience, manage system resources, and integrate with existing enterprise systems. This method is often preferred in corporate environments where IT departments need to deploy applications to multiple machines consistently. One of the key benefits of MSI is its ability to support silent deployment, where the installation occurs without user interaction, making it suitable for large-scale rollouts. However, this method also presents challenges. Managing dependencies can be complex, as missing or incompatible libraries may cause installation failures. Additionally, ensuring compatibility across different Windows versions and hardware configurations requires careful testing. Despite these challenges, MSI remains a reliable choice for applications that require deep system integration or custom installation workflows. Web-based deployment involves hosting applications on web servers so that users can access them through a browser without the need for installation. This approach offers several advantages, including cross-platform access, as users can run the application on any device with a web browser. It also eliminates the need for users to download and install software, reducing the barrier to entry. Tools like ASP.NET and Internet Information Services, IIS, are commonly used to build and host web applications, while cloud platforms such as Microsoft Azure provide scalable infrastructure for deployment. Web-based deployment is particularly well suited for applications that require real-time collaboration or data sharing, as the server handles processing and storage. However, this method relies on a stable internet connection, and developers must ensure the application is optimized for performance and security. By leveraging cloud services, developers can also benefit from automatic scaling, backup, and maintenance, making web deployment a flexible and efficient option. Versioning and security are critical considerations in any deployment process. Version control involves managing changes to the application over time, ensuring that updates are released in a structured manner. This includes using incremental updates to introduce new features or bug fixes while maintaining backward compatibility. Rollback strategies are essential in case an update introduces issues, allowing developers to revert to a previous stable version. Security measures such as code signing help verify the authenticity of the application, preventing tampering or unauthorized modifications. Permissions should be configured to restrict access to sensitive parts of the application, while data encryption ensures that information remains protected during transmission and storage. Compliance with legal and organizational standards, such as data protection regulations or industry-specific guidelines, is also crucial. By addressing these factors, developers can build trust with users and ensure the application operates securely and responsibly. Adhering to best practices for deployment can significantly improve the success of software releases. One of the most important practices is testing the deployment in a staging environment that mirrors the production setup. This allows developers to identify and resolve issues before they affect real users. Automating updates using tools like PowerShell or continuous integration and continuous deployment CI/CD pipelines can reduce manual effort and minimize errors. For example, a CI/CD pipeline can automatically build, test, and deploy updates whenever code changes are committed. Documenting deployment procedures and user instructions is equally important, as it ensures that both the development team and end users understand how to handle installations, updates, and troubleshooting. Clear documentation also facilitates knowledge sharing and reduces the risk of errors during future deployments. By following these practices, developers can streamline the deployment process and enhance the overall user experience. Troubleshooting common deployment issues requires a systematic approach to identify and resolve problems efficiently. One frequent challenge is dependency conflicts, where the application relies on specific libraries or frameworks that may not be present or compatible with the target system. Resolving this often involves ensuring all dependencies are included in the package, or using tools like the Microsoft Net framework setup to install required components. Logging and error handling are essential for diagnosing issues, as they provide insights into what went wrong during deployment. Developers should implement robust logging mechanisms to track errors and user interactions, making it easier to pinpoint the root cause. Validating compatibility across different systems is another critical step, as an application that works on one machine may fail on another due to hardware or software differences. By addressing these issues proactively, developers can ensure a smoother deployment process and reduce user frustration. Post-deployment maintenance is vital for ensuring the long-term success of an application. Monitoring application performance through tools like performance counters or application monitoring software helps identify bottlenecks or resource issues. User feedback is also invaluable, as it highlights areas for improvement or potential bugs that may not have been caught during testing. Scheduling regular updates and patches is necessary to address security vulnerabilities, add new features, and enhance functionality. This includes keeping dependencies up to date and ensuring compatibility with new operating system versions. Providing support channels, such as a help desk, online forums, or documentation, allows users to seek assistance when needed. By maintaining open communication with users and continuously refining the application, developers can foster trust and ensure the software remains relevant and functional over time. In conclusion, effective packaging and deployment strategies are essential for delivering reliable and user-friendly software. Click Once, MSI, and web deployment each offer unique advantages, making them suitable for different scenarios. Click Once excels in ease of use and automatic updates, while MSI provides greater control for enterprise environments. Web deployment enables cross-platform access and scalability, making it ideal for modern applications. Packaging plays a crucial role in the user experience, as it ensures that all components are included and configured correctly. By understanding the principles of deployment and experimenting with tools like Visual Studio, developers can create robust solutions that meet the needs of their users. Encouraging hands-on practice with these tools will help solidify theoretical knowledge and prepare developers for real-world challenges. The capstone project serves as the final and most significant component of this Visual Basic programming course. It is designed to bring together all the knowledge and skills you have acquired throughout the training, allowing you to create a fully functional application that mirrors real-world scenarios. By working on this project, you will not only demonstrate your technical proficiency, but also apply critical thinking to solve complex problems. This process will sharpen your ability to design efficient solutions, write clean and organized code, and adapt to the challenges that arise during development. The capstone project is more than an assignment. It is an opportunity to showcase your growth as a programmer and prepare for future professional endeavors. Before diving into the technical aspects of your application, it is essential to establish a clear plan. Begin by defining the primary goals and scope of your project. What problem does your application aim to solve? How will it benefit its users? Identifying the target audience is equally important, as it will influence the design and functionality of your software. Consider the needs and expectations of the people who will use your application. Once you have a vision, create a timeline with specific milestones to keep your progress on track. A well-structured checklist will help you break down tasks into manageable steps, ensuring that you meet deadlines and maintain focus throughout the development process. Designing the application is a crucial phase that requires careful consideration of both user experience and technical requirements. Start by sketching user interface mockups to visualize how users will interact with your software. These mockups can be created using simple tools or digital design platforms. Next, plan the data structures and database integration if your application requires storing or retrieving information. Understanding how data will flow through your program is vital for ensuring efficiency and scalability. Finally, decide on the technologies and libraries you will use. Whether it is leveraging built-in Visual Basic functions or integrating external tools, selecting the right components will impact the overall performance and flexibility of your application. Implementing core features is where your planning translates into action. Begin by developing the essential functionalities of your application step by step, ensuring each component works as intended before moving forward. Writing modular code is key to maintaining clarity and ease of updates. By organizing your code into reusable sections, you enhance readability and simplify future modifications. Additionally, incorporating error handling and user feedback mechanisms will make your application more robust and user-friendly. Anticipate potential issues and design solutions to guide users through common pitfalls, ensuring a seamless experience. Once the core features are in place, you can enhance your application by integrating advanced capabilities. This might include implementing data validation to ensure accurate input, adding animations for a more engaging interface, or connecting to external APIs to expand functionality. These features require careful planning to ensure they work harmoniously with existing components. Pay attention to the interactions between different parts of your application, as seamless integration is critical for a polished final product. Finally, optimize performance by refining code efficiency, reducing resource consumption, and ensuring your application runs smoothly even under demanding conditions. Testing and debugging are essential to ensure your application meets the desired standards. Start with unit testing, where you evaluate individual modules for errors or inconsistencies. This step helps identify and fix issues early in the development cycle. Next, conduct user acceptance testing by inviting real users to interact with your application. Their feedback will highlight areas for improvement and reveal unforeseen challenges. Use this information to refine your software, addressing bugs and making adjustments to enhance usability. Remember, testing is an iterative process, and continuous improvements will lead to a more reliable and user-centric application. Preparing your application for deployment involves several key steps. Begin by packaging your software into a format that is easy to install and distribute, such as an executable file or a setup wizard. Comprehensive documentation is also crucial, as it guides end users through the installation process and explains how to use the application effectively. Additionally, create a maintenance plan to address future updates, bug fixes, and feature enhancements. This ensures your application remains relevant and functional over time, providing long-term value to its users. In conclusion, the Capstone project is a journey that combines planning, design, development, testing, and deployment. Each step plays a vital role in creating a successful application, and the skills you gain through this process will serve you well in future projects. Remember that teamwork, creativity, and persistence are essential in overcoming challenges and achieving your goals. As you complete this project, take pride in your work and consider showcasing your application as a portfolio piece. It is a testament to your abilities and a valuable asset when pursuing further opportunities in the field of programming. And just like that, our dreamy coding adventure has come to an end. I hope the gentle ebb and flow of the tutorial, combined with the tranquil melodies, have left you feeling both informed and at ease. Whether you managed to catch every line of code or drifted off into a peaceful slumber, remember that the world of Visual Basic will always be here waiting for you. Keep your code clean, your mind open, and your spirit relaxed. Don't forget to subscribe to Code Snooze so you never miss out on another soothing coding journey. Hit that like button if this video brought you a moment of calm and learning, and share it with fellow coders or anyone in need of a serene study session. Thank you for joining me in this cozy corner of the internet. Until next time, may your code run smoothly and your dreams be filled with brilliant algorithms. Sweet dreams, sleepy coders.